today. So just for you to know. And also, as you probably noticed, we passed around a survey for gender assessment. So I hope you can fill this out So the chair of today's sessions is Marta Losada. So Marta, please take it away.
Yeah, thank you, Rogerio. Okay, so we will start with the plenary talk on astroparticles given by Federico Sanchez. So please, Federico, you can start.
Okay. Hello, everybody. Let me go to the start. So welcome to the astronomy, astroparticle, astrophysics topic of today. This presentation was prepared by Juan Carlos Dolivo, by myself, and by Martin Subieta. So Mexico, Argentina, and Bolivia members. Let me start saying that our task was somehow easier.
Sorry,
probably.
okay, we're not seeing your slides.
Oh, sorry. Let me see again. I was not sharing the screen. That's why. Okay. Are you seeing now?
Yes.
Okay, perfect. So I was saying that our task was, and the papers we received were based on project. So somehow this subgroup was easy to identify because all these projects have a very well-defined physics drivers and constructors, and therefore the organization would we base the organization of the talk going through the experiment. We received actually 5 white papers, 2 regarding the same project, the CTA, Cherenkov Telescopes Array, and for other different, but in a later stage, we also decided to include the JAMA project, the Latin American Millimeter Array, that was not present when the call for white paper ended. But we consider it's an important project that have to be there. So here are the names and the acronym of the 5-6 project. We will review. Sorry for introducing a Y into the name in acronym of the SWGO Observatory, but for me it's easy to pronounce with the Y there. So let's go immediately to something that we would like to stress regarding the project we have to review, that and is that 5 out of 6 of this project are already or will be in the near future hosted in our region in Latin America. So and these are the 5, except for Grant, that it's a observatory that it is conceived in stages, and the very end stages they plan to deploy very many subarrays, and it could be feasible that some of these subarrays may be also in our region, but this is, let's say, somehow far in the future, and all the others are already here or will be here in the near future. And on top of this, we also have to say that 2 of them, the Piero Observatory and the LAGO, are already operative, already running since several years. So what are the three projects that has already decided where they will go are the Cherenkov Telescope Array, the Piero Observatory, of course, that is running since 20 years, and also the JAMA project. Two of them are in Argentina, in two different places on Argentina, very distant from one from the other, while CTA will go to Chile. The other one is LAGO, which actually is has not one side, because actually it is a network of detectors spanning over all our region. They have detector in Mexico, and they have even put detector in the Antarctica Peninsula. So it's a wide area they cover, spanning all over Latin America. And finally, SWIGO is going to be in Latin America, because among all the sites they are looking at, all of them are in our region. There is a site in Chile, there is a site in Argentina, one in Bolivia, and one in Peru. But what we like to stress here is, irrespective of which one will at the end be the place, is that three of them, the places they are looking at, are very close by the other projects. In Chile is close by the ALMA project. In Argentina is very close to the JAMA and the Cubic site. In Bolivia is close to the Alpaca site, and the only exception to this is the Peruvian site. And this is telling us something, and that's why we put it here. Is that light is showing us how one running experiment somehow pull other experiment to come to our region. So this is a very important aspect of the sites that SWIGO is looking at. And okay, and I already said about grant that is in the prototype phases in China, but they are looking for in the future to deploy several subarrays, and maybe one in Latin America. So the first thing that we would the first message we would like to send to the forum is that our area, the astronomy, the astroparticle and astrophysics area, has already shown how to host a large international project, really foster the community in several aspects, from the human resources to technology capability, and how this running this large collaboration is somehow pull other collaboration to come to our region. And in particular, in the astronomy, astroparticle, and astrophysics, which I shortly put here, like Astro 3 subgroup, we have a lot of advantage to offer to collaboration or projects that are looking where to install the detector, their observatories. And here I would like to quote something that I heard in the 20th anniversary of the Piero Observatory by Nando Ferroni from the ENFN, which I think that speaking about or sharing this case, he said something like that we have demonstrated after running this huge collaboration in our region, that doing big science and running and conceiving a large project is not a prerogative of only of the developed country. So we have demonstrated that we can do it, and certainly this pull a lot for other collaboration to come to the region, and this is a very important message. Okay, so but of course in the context, in the more scientific context, all these experiments that look at different aspects and different phenomena also talk to each other. So having them working in a cooperative mode, in what somehow is called this multi-messenger era, where some of the observatory may be triggering for others that are the followers of observatory, looking at how things evolve with time. It's a very advantage to having close by and in a cooperative way. But of course, for doing all the nice science that this project want to do, we need money, and so I put here, or we put here, two things: the participation of the Latin American countries in each one of these project, and also the overall budget they are putting in the white paper. So going from one extreme to the other, if, for example, we have LAGO, which is basically a Latin American project, because 10 countries are participating in it, and its budget is relatively small. It's $1 million. We go to the other extreme, which is grant, which at the very end of the project, the total project may cost something like $230 million, and so far only one country in the region is participated. And of course, we have all the gray zone where things are more or less in between. So we have the Swigo Observatory with the participation of 4 Latin American countries and a cost of $54 million, very similar to what the Hiroshima Observatory was. And here I separated what was the cost of the construction of the Hiroshima Observatory, and now what is the upgrade. And the JAMA project, which counts with the participation of Argentina and Brazil, it cost $25 million. So once we saw this picture, there is like a natural question of if this picture more or less balance for project that I like to insist is are host in our region. So here we put in a pie chart the participation of the country of the regions and the cost, and in between parentheses here you see the total amount of countries that participate in each of the programs, in each of the projects. And as you see, LAGO is, as I told you before, almost completely Latin American project, because only one country out from our region is participating, which is Spain. In very similar situation as the Piero Observatory and Swigo, with 4 countries of the region and 10 countries out of our region participating. We have CTA with 3 over 31. This is the larger collaboration. We have JAMA, which is only also so far a Latin American project, with the 2 countries, Brazil and Argentina, participating out of 2. And finally, grant, which is still a small collaboration, because it has in total only 6 country, and Brazil is participating. But as we pass to the cost, you see that basically the big big portion of the pie is covered by CTA and grant in the total cost. So we simply run the very naive exercise with, okay, let's take the ratio between the cost and the countries of our region that are participating, and the picture is what you can see here. Again, CTA and grant has the bigger size of the pie, and the other three, the Piroget, Suigo, and Llama are here. And as you see here the number, but the portion of the pie is completely disappeared for LAGO. So what would like to stress here, it's very naive approach. Of course, there are several things related to the technology that is used and the total size of the collaboration that is driving the cost, of course. But in any case, these are, for example, I will take example of CTA. It seems that this is a very important project. It has a large collaboration, many countries in it. Their costs are proportional to the collaboration size, but it seems that we need to increase our participation for this project of countries of our region. We have to take the advantage of having this nice project coming to our region, and it seems that that we, from making this game, we may see that we need to increase the participation for strengthen the community in this topic. And on the other side, it's playing this game. It seems okay. LAGO, it seems that need more investment because it's very important for our region. A lot of countries of our region participated, but they almost disappear. But this, of course, has to do mainly with the technology. So this is just a game. So don't take it too serious. But it's there is something there that we can take from for discussion later on. Okay, so let's go to some details of the for the project. Let me start with SWIGO. This is a gamma ray observatory. The technology they will use, as you will see in the presentation, are based on water Cherenkov detector. They need a relative small area for detection, going from 0.8 kilometers square to 0.2 kilometers square, with a different array of spacing of detectors. They have several advantages, as you will see. And as I told you, this is a collaboration which involves 43 institutes from 10 countries, and 4 of them are in our region. They need still to select the candidates, the candidate site, the site. So the candidates are the ones that you can see here, and I told you before. And they are planning planning a timeline for the observatory that covers this year's, more or less. What are their goals? So basically, they will look for very high energetic gamma rays, studying the pulsar wind nebulas and the halos of the pulsar wind nebula, identify pevatrons, sources of galactic cosmic rays, study the Fermi bubbles. So I won't go into all the details of this science, because you will hear more in the following dedicated talks. Sorry. So LAGO, as I told you again, is a network of detectors spanning over all the region. They are also based on water Cherenkov detectors. It's also the cost because it's a cheap technology. They go from very high altitude sighting at high altitudes in Bolivia to low sites in altitude in Buenos Aires, but as I told you, they also have detectors in Antarctica. And the collaboration involves 29 institutes from 11 countries. As I told you before, the only one that is not from our region is Spain, and the budget is it's quite low. It's $1 million, and the timeline it's more or less from 2005 that they started towards some year in the future. So the basic goals they are aiming to study or search the gamma ray events and study the modulation and the anisotropy at a different location on the Earth of the galactic cosmic rays. They also are able to do space weather studies. Okay, so let's pass to GRAND. GRAND, as I told you, it's conceived as a network of detectors that to be built in several stages. They are now facing the GRAND, what they call the GRAND Proto certified. Certified stands because they have certified detectors, and then they will move to GRAND Proto 300, then GRAND 10Ks, and GRAND 200K will be the end of the project. And this prototype is being built in China, and it's based on radio antennas. So they have quite good sensitivity and very nice resolution. So and the main observables are related to neutrinos and ultra high energy gamma rays. So but as I told you before, this is still a small collaboration. Only 80 institutes from 6 countries are participating, and Brazil is the only one from our region. And the cost is $230 million for the very last stage of the project. Okay, as I told you before, these are the list of physics goals they are aiming at. Basically, study the neutrino and contribution to the neutrino science. Okay, let's pass to CTA. CTA is based on the very successful technology of the imaging, the Cherenkov light in the atmosphere by the telescopes. It is conceived as a dual observatory, one in the south and one in the northern hemisphere. And the sounds, as I told you, is the site selected is in Chile. And this is a huge collaboration with 200 institutes from 31 countries. And we have here highlighted the 3 countries of our region that are participating, and the total and the total cost. This is for the construction only. So something that we also have to start thinking of is that after the construction we have to still participating for maintaining and operating this kind of large collaboration. and this in the strategy view is something that we also have to bear in mind. So we group the main drivers of CTA. You will see it also in the dedicated talk, but basically they are aiming at answer questions related to these three main topics, which is understanding what is the origin and the role of the relativistic cosmic particle, probing in different ways extreme environments, and also doing some physics at the frontiers, so studying the matter and so on, and physics beyond the standard model. So we come to the Piaget Observatory, which actually is an observatory that was running since 20 years in Argentina, but since 2015 is also dedicated to upgrading all its detection system. It's covered a very large area, 3,000 kilometer square, and it has a combination of technology in its site based on water Cherenkov detector again, but also fluorescent telescope. Now in the upgrading phase, also plastic scintillator detectors. It has also radio antennas and has prototype of RPCs, resistive plate chamber, where the even though this will be not cover the full area. The collaboration is also big. It comes with 80 institutes from 17 countries, and 4 are from our region, and the cost is the one that I told you before. The timeline for the upgrading the detector is, as I told you, started in 2015, and will end probably at some in some year close to 2037. Basically the Piaget Observatory already produced a lot of results, so I won't go through them. But what we have learned in all these years running the Piaget Observatory is that we need to improve the mass composition. I say we because I'm part of the Piaget Observatory. Sorry for that, but we are trying to improve the mass composition at the very high energy to fully understand the picture of the flux suppression that is seen at the very high energy, and what is the contribution of protons at this energy, and in this way we will be also able to contribute to hadronic physics. So the aim of the project is to study the cosmic ray from this energy 10 to the 17 up to 10 to the 20 is very high details. So let me finish with SHAMA. SHAMA is a radio telescope that is being also built with the participation of Argentina and Brazil. Only two countries. Is a single dish telescope of 12 meters diameter. It's very similar to the ALMA or ALMA telescope, and also the place where it will be installed in the province in the province of Salta in Argentina is in the very same latitude of the ALMA project, but on the other side of the Andes. So the physics aims of SHAMA are quite a lot. Also solar physics, cosmology, galactic structure, astrochemistry, interstellar media, study the star formation and polarization, and the magnetic fields. But also these are things that can be done with single dish study, but in the future the idea behind JAMA is also to observe in combination with JAMA in order to do very long base baseline interferometry with the two sites, and improve a lot the precision of the measurement. And basically, this is, I think, something relatively new in the project. They plan to install a bolometer in one of the cabins that has the telescope, in order to do also to study also the polarization of the CMB, but differently to what qubit does. This will be studies at smaller angular scale than qubit, and therefore will complement what the cubic observation, which are at larger angular scale. And okay, so this brings me to the conclusion. Again, I will repeat myself, or we will repeat ourselves in the message. We believe that in this field we really has a strong opportunity to pull large international collaboration to come to our region and install the project in our region. And this certainly is it's a way to strengthen the science and the technology of our region, as we learn participating of some of this already running project. The region has a strong commitment in this field. This has to be said, and count with very good advantages with respect to other sites that could compete all over the world. But having said that, it's also desirable, as I told you before, for example, for the case of CTA, that we need to further increase. We need to take profit of this opportunity of having these observatories here, in order to increase the participation of the countries of the region in a strategical view in this project, in all these projects. So I think this is it.
Okay, thank you very much, Federico. We will have questions in the discussion session. We'll continue on now with the next talk. Is Elisabetta Del Pino on CTA. Please, Elisabetta, go ahead.
So hello, everybody. I'd like to thank the organizers for this opportunity to talk about CTA, the Cherenkov Telescope Array, that will be the world's largest gamma ray observatory ever built of Cherenkov telescopes, ground-based Cherenkov telescopes. Next slide, please. Cherenkov radiation is excited when an electromagnetic cascade produced by a gamma ray coming from space impinging into the atmosphere, right? And this radiation produces a light pool of 0.1 kilometers squared extension on the ground. And one requires several detectors or Cherenkov telescopes in order to catch the entire pool, right? So next slide. CTA will be a global observatory of more than 100 such telescopes, spread in two sites for full sky coverage, one in the north and the other one in the south. The north one is already in construction in Canarian Islands in La Palma, and the south one will be in Paraná, Chile. Next slide. CTA Consortium has 31 countries spread all over the world. Next, please. And now CTA has entered the construction phase, and CTA will have 10 times more sensitivity than any current instruments, and it will cover a large collection area, and we'll have a the widest actually energy cover in gamma rays, down to 220 GeVs which is excellent for cosmological observations, up to 300 TeVs, which will be excellent for probing the highest cosmic ray accelerators. The wide field of view of 8 degrees will be excellent for surveys and observing extended objects. And the resolution will be few arc angular, minute resolution, which is will allow for the first time to do morphological resolution observations of sources like supernova remnants, for instance. Next slide, please. In order to fulfill these requirements, CTA will have 3 different size telescopes: the large size, the medium size, and the small size telescopes. Next, please. They will be distributed like this figure shows for the southern array, which will be the largest one. Next slide, please. There will be 4 23 meters diameter large size telescopes in the core that will probe the range to observe more distant objects. And there will be 25 middle-sized telescopes for intermediate energy coverage. And next slide, please.
Next one.
Excuse me? Can you?
I miss you or you miss me?
Yeah, I think I did miss you because I asked for you to change the slide. Could you please go back to
This one?
Yes, this one.
Okay.
So, and there will be 70 4 meter diameter small size telescopes spread all over the array, and they will cover the largest energies up to hundreds of TeVs, and they are spread over 10 kilometer squared area, exactly to cover or to capture the entire light pool of the highest energy gamma rays. So next slide, please. Okay, Brazilian involvement. We have ASTRI. Next, please. Okay, there are about 60 Brazilian people involved in CTA from 12 institutions, but the leading institutions are the Institute of Astronomy of USP, the Institute of Physics of São Carlos, and CBPF in Rio. Next, please. The group of VAG USP is collaborating with the Italians in the development of the small size telescopes, the ASTRI SSTs, which will compose the 70 SSTs for CTA. And our group, which is led by myself, is also involved in the construction of the so-called ASTRI mini array, which will be a precursor of CTA. But Reinaldo Santos-Lima will talk more detail about this right after me. Next slide, please. The São Carlos group is involved in development of structures for the middle-sized telescope, more specifically the support of the camera, and Vitor will talk about this later. Next slide, please. The group in Rio, they are involved in development of support components for the mirror structure of the LSTs. Next. The Latin American participation in CTA so far. Okay, with regard to the budget, CTA will require around 400 million euros. And if we consider that there will be 31 countries, there might be an average contribution of 13 million euros, more or less, per country. Brazil so far has contributed with 3.5 million euro, most of this with FAPES funding to the projects of the University of São Paulo that I have just described. And Chile has secured 1 million euro. Next slide, please. Okay, the science scope of CTA is very broad, encompassing studies from galaxy sources to extragalactic sources, galaxy clusters, and also a dark matter program. Next, please. Next slide. The 10 key science projects are here listed, and they are described in detail in this book, Science for CTA, that we published last year. Next slide, please. Okay, the main goals, as said before, are understanding the origin of relativist cosmic particles, where and how they are accelerated in the universe, probing extreme environments like the surroundings of neutron stars, black holes, relativistic jets, the origin of cosmic magnetic fields in voids, and exploring the frontiers of physics, the nature of dark matter, the quantum gravity effects on photon propagation, and the existence or not of the axion particles. Next slide, please. So the CTA performance is intended to be a factor of 5 to 20 times bigger than any current instrument, as shown in this figure of the flux sensitivity. Next slide, please. As an example, this will be the current reach of the current instruments in the galaxy, in our own galaxy, is only this small circle, and CTA will encompass the entire galaxy, as you see, in capturing very high energy sources in the galaxy. Next slide, please. Okay, the expect to observe thousands of very high energy sources in the extragalactic domain, and explain the discovery of more than 300 extragalactic objects. Next slide, please. CTA will be a high energy transient monitor as well, with the orders of magnitude advantage over Fermi-Lati. Next slide, please. And also the main experiment for dark matter search through the annihilation of WIMPs, right? As this figure shows the sensitivity, for instance, for the search of dark matter annihilation in our galactic halo. Next slide, please.
Elisabetta, you need to wrap up, please.
Yes, it's. I have just 2 slides more. CTA will also participate in large multi-wavelength follow-up campaigns. And finally, the final slide. Yeah, yes, the last milestone. Okay, CTA North has already started construction, as I said before. The South will start the site preparation after the pandemics, and we intend to deliver until 2022-25 what we call the threshold implementation. That will be 9 telescopes in the north and 65 in the south, and after that, then we will continue to the final goal, that is the construction of 118 telescopes in the 2 sites. Thank you.
Thank you so much. We'll continue on now with Reinaldo Santos on the ASTRI mini array presentation, please.
Hello.
Next slide. This is yes. This is getting.
Yes. Okay. Good morning to everyone. Thanks to the organizers for this space to present this ASTRI project, which is a collaboration inside the CTA larger project discussed by Beth in the last talk. So next slide, please. I work in IAG. I'm a professor in IAG, and I am also part of the Brazilian ASTRI team, led by Elizabeth through her FAPESP thematic project. The INAF, Instituto Nacional de Astrofísica, is the leader of this program, which besides USP Brazil has the collaboration of the Northwest University in South Africa and the Instituto de Astrofísica de Canarias in Spain. Next, please. So the ASTRI team has developed this prototype, this figure, this photo in the left side. Is a prototype for the small size telescope to operate the highest energies of the CTA. And besides providing this project for this SST, small size telescope, the ASTRI, this collaboration, ASTRI collaboration, aims also to build the independent array of 9 telescopes to operate before the full CTA. So it will work as the precursor of the CTA. Next, please. This ASTRI telescope has this dual mirror design with the primary mirror of 4 meters segmented and the secondary one with 2 meters of the diameters in front of it in this Schwarzschild called the optical design in order to collect the Cherenkov light. The camera has silicon photomultiplier sensors with fast electronics. And this telescope was designed to have the maximum sensitivity to detect photons of about 1 tera electron volts. And it will operate detecting photons up to about 300 tera electron volts. It's going to be the first telescope to operate at these high energies. Next slide, please. So the telescope the prototype was inaugurated in 2014. So it shows this picture in Catania, Italy. So in the middle of the pictures, 2 members of the Brazilian team, Elizabeth and Rodrigo Nemen, are present. Next, please. And the optical validation was published in 2017. And in 2019, the prototype made his first detection of the Crab nebula in tera electron volts. Next slide. So this prototype has been tested now for 4 years. So this testing period led to improvement in the design. So this final design is lighter than the prototype. And the telescopes of the mini array, the 9 telescopes, are already in phase of production. The structure of the first one was manufactured with resources from Elizabeth's FAPESP thematic project. And the same project has already sent fundings for the constructions of 2 other structures. So a total of 3 of the 9 telescopes of the array were founded, the structures at least, with Brasilia, from the Brazilian part. So this first telescope that is ready will be transported to the site it's expected by the end of this year. Next. It shows, this plot shows the sensitivity, the flux sensitivity as a function of the energy. So it shows the extension compared with existing imaging atmospheric Cherenkov telescopes, MAGIC and Veritas. The extensions, the ASTRI, the red dots, the ASTRI, will extend the sensitivity to dozens to hundreds of tera electron volts. And it shows also it's going to be competitive with the Hawk experiments. The Hawk is this upper green line. Next. So the next slide shows the parts of the galaxy accessible from the ASTRI sites in the Northern Hemisphere in Tenerife. So it includes some Pevatron sources in the galaxy, as well targets out of the galaxy. Next. The mini array is expected to start operating by 2022. So about 3 years before the full CTA. And the scientific program of the ASTRI mini array includes many galactic sources as well extragalactic sources. So it will start to explore some of the fundamental physics questions addressed by the CTA scientific program. And I would like to enhance the synergy expected between the ASTRI mini array and the HECAP, because ASTRI has better angular, is expected to have better angular resolution, so it will possibly resolve especially the sources detected by HECAP. Next. So this slide shows the map of the observatory, the place of the observatory in Tenerife, the Canary Islands, and there will be two control centers in the islands, and the data will be transmitted to the continent via a high-speed connection to be analyzed and stored in Italy in a control center in Rome. Next. So this map shows displays the configuration of the array. So in this map, the yellow circles are the places of each of the 9 telescopes of the mini array. So the distance between telescopes is between 100 to 200 meters, and total size of the array is about a half kilometer. Next. This slide shows on the left side some photos of the mirrors. They were already produced by the 9 telescopes, the primary and secondary. And the camera was developed in collaboration with a Brazilian engineer of our team through the FAPESP thematic project led by Elizabeth. And now the cameras are in bidding process for starting the manufacturing. Next. The final design of the structure of the telescope is about 25% lighter than the original, than the prototype, which is very good for fast pointing to the sources. And the control software for this telescope was also developed in collaboration with a Brazilian engineer of our team, Carlos Firmino. Next. This, as Elizabeth showed in the previous presentation, the CTA Observatory foresee in the south site the presence of 70 small-sized telescopes, and the ASTRI telescope was chosen as the model for these SST small-sized telescopes. Next. So it was choosing the ASTRI telescope structure with the check, a compact high-energy camera developed by other CTA teams from UK, Netherlands, Germany, Japan, and Australia. Next. So just to show, Beth is the leader of the ASTRI Brazilian team, and she's also member of the editorial board of the SST program proposal. So this slide show also the partners, the involved countries and institutions working in direction of the SST consortium. Next. So our participation so far includes collaboration for the development of the ASTRI telescopes and the construction of 3 structures. And also our involvement includes several fellowships associated with the ASTRI and CTA projects. And our team also organized an advanced school on high energy astrophysics. Next. And
Nada, you need to wrap up, please.
Okay. So just to enhance again the participation of the Brazilian engineers in the development of the camera, it was the engineer Renato Jimenez next who participated in this development, and also in the software control, the engineer Carlos Firmino next. Currently, the CTA, Brazilian team has about 60 members, 29 only these ASTRI SST projects. And remember from Betty's presentation, I don't know if she mentioned it, aim to produce 10 to 11 of the 50 ASTRI SST structures for the CTA South Array. And my last slides, sorry for passing the time, the status of the SST consortium. So currently the SST model composed by the ASTRI structure with the check camera is under design review for harmonization of these two components. And the SST organization is being prepared and implemented. And after this phase of critical design review, it will follow the manufacturing of the SST telescopes. And of course, the SST consortium work on the verification, transporting, and installation of the telescopes in the site in collaboration with the CTA Observatory. Thank you very much.
Thank you, Reinaldo, very much. We continue on now with the next presentation. Is Carola and Dobrigkeit. I'm talking about AugerPrime, the Brazilian contribution. Yeah.
Thank you very much, Marta. Good morning to everybody. Bom dia, buenos dias. Next, please. I am in the comfortable position to talk about a project that everybody has at least heard about many, many times. So you are familiar with it. The Pierre Auger collaboration is a large collaboration involving 17 countries. I have to correct myself. Fede reminded me that I forgot Belgium, which just was accepted in the collaboration. But anyhow, we have, next please, we have 4 countries from Latin America involved in Auger since almost the beginning: Brazil and Argentina, Colombia and Mexico. Sorry to mention it not in alphabetic order. Next slide, please. In total, we have 30 institutions involved in Auger from these 4 countries, and almost more than 100 members. So we are a large part in Auger. We have a very important role. Next, please. The Pierre Auger Observatory was built 20 years ago. The construction started 20 years ago and had the aim to study the most energetic cosmic particles that reach us at Earth, those with energies above 10 to the 17 electron volts. We are collecting data since 2004, so we have over 16 years of data accumulating the world's largest exposure in ultra-high energy cosmic rays. These data have already led to major breakthroughs in this field. But at the same time that we had made breakthroughs and large important discoveries, we have also new questions raised and that need to be addressed. And for this purpose, we have begun an effort to update, to improve our detection of cosmic rays. And this new project is AugerPrime. And we are starting, next please. As you know, we have been using Cherenkov detectors on the surface, 1,660 tanks, water Cherenkov tanks, 27 fluorescence telescopes, underground muon detectors, radio antennas, and monitoring, and many instruments were joined during this 20 years of operation. But now we will improve this all, to see what we have to check and improve our measurements that we have made through these years. I will mention only a few to motivate you. And this one is the energy spectrum, which we have observed and presented now. We will publish a new paper soon about the energy spectrum. And you see that we are covering 4 decades of energies and presenting the features in the spectrum over these 4 decades of energy. Next, please. We have studied mass composition of cosmic rays arriving at Earth through the study of the longitudinal development of the cascades induced by cosmic rays in the atmosphere, and showing the variation of the composition from what we see in the data. Next, please. We have been studying large angular scale anisotropies in the sky with the recent discovery of the first indication that the extragalactic origin of the highest energy cosmic rays with a dipole above the energy of 10 to the 18 electron volt, showing a dipole which is pointing 125 degrees off the galactic center, indicating the extragalactic origin. And this dipole is increasing with energy. Next, please. We have studied also intermediate scale anisotropies, correlating our cosmic rays with starburst galaxies and AGNs. Next, please. And finally, just to mention a few of our results, we have studied the muon content in air showers, and showing that our simulations fail to reproduce the data that we observe in the experiment. So to understand a lot of things that we are seeing in the data, measurements, and which we do not understand, we were motivated, next please, to improve our detectors. You see, since we have started to build Auger 20 years ago, many things, many detectors, many electronics have been improved in these 20 years. So it's very logical that we modernize and improve our detection. The motivation for our upgrade for AugerPrime is studying the origin of the suppression in the energy spectrum observed at the highest energies, and improving the mass composition measurements and our knowledge about the composition, we will try to select showers of light particles, which are those that are less deflected by the magnetic fields intervening in their propagation up to us. Then we can also, knowing better the composition, we will improve our estimates of neutrino and photon fluxes, and anyhow contribute to the knowledge, improving the knowledge about hadronic interactions. Next, please. Just a photo of one of our old tanks, modernized by a scintillator above, on the top of it. And like this, each one of our 1,600 detectors will be improved by a scintillator detector on top of it. Next, please. The upgrade includes many steps. One of those is this plastic scintillator detectors on the top of each existing water Cherenkov detector. Then an extension of the underground muon detectors, which are under the responsibility of the Argentinian part, and also an extension of the radio antennas, so that we can detect the various components of the showers through many detectors and getting a better picture of what we see. The electronics is being substituted by a faster one to improve our data acquisition, and also focusing on the highest energy events and particles that arrive at Earth. We will try to avoid any saturation of the surface detectors by adding new photomultiplier tubes in the detectors. Finally, we hope to extend the operation time of the fluorescence, the telescopes, which operate only, as you know, only at night. We will extend the duty cycle of those telescopes, operating them for longer times in the night. We are presently installing all these detectors. Of course, the pandemic has brought a halt on that, but we hope that we will operate the extended and improved observatory far up to, let's say, I will not be so optimistic like Fede to say 2030, let's say more than 2025, which is what we had foreseen at the beginning of our plans. Next, please. I cannot, unfortunately, I would like to show this film showing the deployment, but it's only possible in PowerPoint. So next, please. Over these years, we have counted with the continuous support of our funding agencies in Brazil. FAPESP has supported us in the construction and is also supporting our expenses for the upgrade in Brazil. We are participating mostly in the upgrade of the surface detectors with the new photomultipliers tubes that are being added. Next, please. I thank you very much. That was the only things that I wanted to mention. Thank you, Marta.
Thank you so much. We will continue now with Ivan on talking about LAGO. So Ivan, the floor is yours.
Thank you, Marta. Thank you, all the organizers, for setting up this meeting. I think it's very, very important that we have this discussion among the LA countries. I'm going to talk about LAGO. Fede already mentioned a lot of things. If you please can go to the next one. You saw this map many times during these days. We have an upgrade. We have one more site. This map shows all the Latin American countries that are part of LAGO, and we have 30 sites with a lot of up and running detectors, and some of them are in deploying phase still. And we have planned at least 3 sites. The one in Sao Paulo is already up and running, but we are just adjusting some minor things. You can see that we go from Mexico. I don't know if you see my mouse, if I can point somehow this, but to Antarctica. We have 2 sites at Antarctica, one at the Marambio Argentinian base that is up and running, and I'm going to tell a little bit more about this later. And the other one is at the Peruvian base. It was very important 2 campaigns to do that. And here is again the list of the countries that are part of LAGO. We have Argentina, Bolivia, Brazil, Chile, Colombia, Ecuador, Guatemala, Mexico, Peru, Venezuela, and also Spain. I like to say it like that because for me it's very important. And there are around 100 members of the LAGO collaborations. And we have 3 major scientific goals that are the study astroparticle physics in the extreme universe, most of them trying to think on GRBs, transient and long-term space weather phenomena. We are trying to focus more on that also, and measurements of background radiation at ground level. LAGO is very important because it has some clear and academic goals. I'm going to repeat myself many times here, but train Latin American students in high energy astroparticle physics is very important. If you go to the next one, please. We work as a non-centralized collaborative network of institutions and scientists. We have 3 working groups, and the coordination of the network is done by 11 plus 1 member and 1 PI. Then we share the developments and hardware, the expertise, and the data among all the networks. So every site has the possibility to access to the data collected in other sites, so we can link studies at different sites. If you go to the next one, please. These are in red, you can see some highlighted things about LAGO, the LAGO Space Weather program. This is very important. We have to study, we aim to study phenomena for ground level and study the connection with atmospheric physics. And also for the LAGO high energy, we use small arrays, or we intend to install small arrays of water Cherenkov detectors and study high energy components of GRBs. I'm going to a little bit faster on this. As I mentioned, LAGO universities, it's about the experiments that you can do with the LAGO detectors within LAGO to train students. If you and LAGO Virtual shows a lot of developments that are made within LAGO. If you go to the next one. So LAGO uses water Cherenkov detectors with very large PMTs, 9-8 inches. The detector is autonomous. We usually use commercial things to build our detectors, except for the PMTs, and we are planning an upgrade in the electronics, and we need a lot of support on that. It is very hard doing that these days. We have many flavors of electronics, but nowadays we decided to use the Red Pitasha from STEM Lab system, and we make some developments to adapt this to our system to control the PMT and trigger and etc. If you go to the next one. This is to show that some of our recent publications, of course, the first one, I went to the REACH workshop, Ring Imaging Cherenkov Detectors, 2016 and 2018. And we usually publish some of the ICRC, some of our developments in electronics, in simulations, and analysis. And we are, and in another space weather conference, you can see here, and we are planning a setup of some publications. This one is going to come out next week. We are going to send it for publication next week, and it's about the simulation chain that we set up from for all the sites in LAGO that takes into account the rigidity cutoff in the atmosphere, and then the shower development in the atmosphere using Corsica, and the simulation of the detectors using GM4. And we also last year set up a very nice workshop in Buenos Aires, and also it was a workshop in the morning and the physics of LAGO school in the afternoon. So if we go out to the next one, please. So last year we set up a kind of roadmap, and we are trying to follow. This roadmap take us to two main things that we want to do. One is the uniformization goals from the detectors and the studies that we made in LAGO, and the other one is are the academic objectives. So we plan, if you can see here, the new electronic design and characterization that I mentioned. It's partially done. Some studies were cut off because of the pandemic. Also, the deployment at the sites it can be done now. It's postponed, and we are still working in the centralization of a data repository and all the analysis chain. And we are always looking for new sites and new places where to install our detectors. I have recently talked to Jorge to maybe we can incorporate Paraguay into the LAGO network. So we are growing each year. And also it was very important milestone, as I said, to install the detectors at Antarctica, and one of them are up and running, and the other is installed, but it needs some work. And okay, we plan 2 schools per year, so this is also one of our main goals. And we held, as I said, the school at Buenos Aires last year, and there was one at Peru at the middle of the year. And well, again, because of the pandemic, the COVID-19 pandemic, the schools that we were planning this year, they are not going to be done, but we replaced that with some virtual schools. So we are running a school on LAGO data analysis that started this week, and it is going to be held for a couple of months, one class per week, let's say. And we have plans for make more schools as if we can. We are trying to make an MOU with Auger to formalize our relationship in data and hardware exchange, and try to see if we can do some joint analysis. And as I said many times before in this meeting, for LAGO to make a uniformization of detectors and to have a stable up and running network, we need a common funding support for all the observatory. We don't have that. We depend only on each site funding that can get. There are a lot of sites that their countries are not as good on that. They don't have some programs for research and development, and we need to change that. And we need this global funding. As you saw from Fede's talk, there is the budget that we need is not so much to get these uniformization goals. So not so much compared to other experiments. So I think this can be done, this should be done, but we need something more global that depending of each site, because also the new sites have always problems in get some funding. Yes, we go to the next one. This is the last one. This is my conclusion. LAGO is you see a very active community within the LA country. We have a lot of project fundings. We made high energy physics studies and a very important training for students. And we set up schools and experiment on each site. And well, okay, that's all. Thank you very much.
Thank you very much, Ivan. We'll go on to the next talk. We have another talk on CTA by Vitor de Souza.
Well, good morning. Thanks for the opportunity. Next slide, please. Within the groups working in CTA in Brazil, I'm going to report here about the work done by the people listed here in this slide. On the right, you can see the supervisors, on the left, the students working within this proposal that is granted mainly by FAPESP, but also by CNPq and CAPS through scholarships. Next, please. So as we all know, astroparticle physics can be used to study sources and can also be used to study the interaction of particles. I think it's fair to say that this project and also the interest of the people listed in the previous slides is more focused on the possibility to study the interaction of particles with astroparticles rather than the power and the way the sources work. Next, please. The topics of interest that I listed in the white paper, and also I'm going to mention briefly in these presentations. Are dark matter, Lorentz invariance violation, and the possibility to test these two hypotheses with astroparticles. Axion-like particles, the possibility to detect the unique signal that comes from astroparticle, and also the propagation of cosmic rays and into instrumentations. We have a strong participation in these topics within the CTA consortium. The CTA consortium has consortium papers in preparation. Nowadays, it's 15 papers being prepared as a consortium. And out of these 15, 3 of them are led by authors of this paper within the subject listed in this slide. Next, please. So this is the general timeline of CTA. We are moving now from pre-construction to construction phase. We are finishing to define the telescopes and how they are going to be assembled on sites. And then we are going to start large production of telescopes to be completed until 2027, when CTA is going to then run fully operational. Next, please. These are the two sites, one in the north, one in the south. As already illustrated, a very good potential for participation of Latin American countries, especially because of this site in Chile, which is going to be the largest one from the two of CTA. Next, please. This is the sensitivity of CTA. So you have the minimum flux that can be measured as a function of the energy of the gamma ray. What I would like to highlight here is first that the CTA North and CTA South are different. You have these two blue lines, these two blue curves showing how the rays are optimized for different physics and astrophysics. Mainly the CTA South aimed at the largest energies for the galactic astrophysics, and the CTA North looking extragalactic with less sensitivity to the largest energies. And the second point I'd like to highlight in this slide is the comparison between the sensitivity of CTA and the current running gamma ray observatories shown in different colors like HES, MAGIC, Veritas, and also Fermi-LAT shown as the green dash and dot lines in the upper left plot. You can see how much CTA is going to improve the sensitivity comparing to the current running experiments. Next, please. Not only the sensitivity, but also the angular resolution. This plot again showed the angular resolution as a function of the energy of the gamma ray. CTA, source, just as an example, comparing to the current running experiments, you can see again an improvement of 5 to 10 in the sensitivity depending on energy, in the angular resolution depending on energy. Next, please. It has been already shown, and I profited from the nice presentation done previously by Elizabeth Dalpino, the main points of CTA, including cosmic particle accelerations, probing extreme environments and physics frontiers. I would say that the interest of the people involved in this project shown here is related to the first and the third points in this slide. So we were working on cosmic particle acceleration and propagation, and the last one, which is related to the physics frontiers, dark matter, axion-like, and Lorentz invariance violation, which shows in this slide as the speed of light is constant or not. Next, please. The book with the CTA science has been published. You can access it in the archive. And I would like also to highlight that CTA is an open observatory, which is a second very nice point for Latin America. The CTA consortium is going to reserve 40% of the observational time for the key science projects that are explaining this book published by the CTA consortium. But the rest of the time is going to be open for proposals, which is again a nice opportunity for everybody in Latin America. Next, please. I'm going to very briefly, in the 5 minutes that I have, illustrate the points we are interested in this project, in this group. First, dark matter detection. We have a gamma ray flux that could be produced by the annihilation of dark matter particles. And the calculation of this flux involves particle physics, as you can see in this orange box. The average cross-section of annihilation of these dark matter particles has to be included here. And also have this bluish box that shows the astrophysical distribution of dark matter you have the line of sight of the telescope, of the observatory. You integrate in this line of sight, and you have the total amount of gamma rays that could be produced and basically detected by any gamma ray observatory. If you have an observatory like Fermi-LAT, you are going to probe only the low energy part, and no signal of dark matter has been detected so far. But CTA has the advantage to extend this to the largest energies, being a region of the phase space that cannot be tested by ground-based experiments. This very high, above 10 to the TeV electron volts, is a region that basically can only be tested by CTA, and if converted to the traditional plot of cross-section versus mass of the dark matter, represents a unique chance to probe this regime. Next, please. This is illustrated in these kinds of plot here for specifically one source, which is the galactic halo. CTA is going to look for the dwarfs as well. So you have here the variation of the average cross-section in velocity as a function of the mass of the dark matter particle. You have this dashed horizontal line showing the thermal relic, which is also a target that we want to measure below this line to be able to probe where we expect the dark matter signal to appear. And you have these other curves showing here different channels of annihilation of the dark matter. And you can see that the sensitivity of CTA would be enough to go to probe the thermal relic cross-section that is a kind of a horizon that we would like to measure through. Next, please. Concerning the propagation and generation of these particles, here's an illustration of gamma rays and protons propagating in the universe, and the universe is not empty; it's filled with radiation and magnetic fields. These particles, they interact with this cosmic background, and they produce different kind of particles in the interaction. If this interaction is well modulated and simulated, we can learn a lot in the process. So we can use the astrophysical accelerators as a source of particles and study its interaction with the background fields until the particles reach Earth. Next, please. With that, you can study exactly the EBL. You can probe the spectrum and the properties of the EBL. This is a study done by Douglas and Edivaldo from the Institute of Physics of USP in São Paulo. They show here different measurements of gamma ray spectrum and relate them to the optical depths of the EBL. It's just an example what can be done. And further questions I would forward to the authors. Next, please. What happens here is that you have these optical depths. You have a universe that is expanding, so you have the cosmological term there of the distance underlined by yellow. And also you have the interaction happening, which is underlined by green. And in this interaction, you can calculate it, supposing Lorentz invariance violation, as illustrated in this example, by changing the threshold of the interaction. The threshold shown in this bottom box depends if you consider Lorentz invariance or its violation. When the violation is added, you get this extra term of delta gamma shown in the bottom equation. And then you can solve this in both ways. Next, please. And study what would be the effect in case of Lorentz invariance violation. As shown here in this plot, you have an spectrum as a function of energy spectrum. You have the intrinsic spectrum of the source shown as a power law on the blue line, and you have the points that would be the measurement done by CTA. So how CTA would measure if you include the Lorentz invariance violation. These are simulations done here in the group that we studied how we could detect Lorentz invariance violation with CTA. And again, this is just an example for one source with one specific intrinsic spectrum. But what I'd like to highlight is that the sensitivity of the current running observatories shown in the plot, MAGIC has and Veritas would not be enough to measure this signal, but with the sensitivity of the CTA, we would have plenty of points above the sensitivity that we could get a signal of Lorentz invariance violation. Again, showing that CTA can give us a lot concerning fundamental physics, including the test of Lorentz invariance violation. Next, please.
Sorry, Victor.
We are working on that. So this is just an example what has been done currently with the current experiments and what we expect to do with situation there. This work, this brownish line, is taken from this paper where we estimated what CTA could do. We can improve a lot our estimation of the limit of the relativity, or if we by chance find the break somewhere in the highest energies. Next, please.
Victor,
not only that, we also, it's
sorry,
just
Victor, you need to wrap up.
One slide, sorry. We are also working in the instrumentation. We are building part of the medium-sized telescope. This project was completely done here in Brazil. You can see there somebody working in the state of São Paulo to weld part of this telescope. Next, please. In the meanwhile, while projecting, we had to develop this, a device to set the position of the camera. This device is shown here in this plot, and a patent was deposited a couple of months ago concerning the innovation developed here in Brazil for CTA. So we have a Brazilian technology in the medium-size telescope for CTA. Next, please. Final slide, just showing the telescope that the gray part was projected and constructed here in Brazil. This telescope was under test in Berlin, and it was now dismounted and is going to be moved to the northern side of CTA soon, showing our contribution in instrumentation. Thanks a lot.
Thank you so much. We continue now with the next talk by Rafael Batista on GRAND. Rafael, please go ahead.
Hello, good afternoon, everybody. I'd like to thank the organizers for the opportunity to present the Giant Radio Array for Neutrino Detection, GRAND, which is a planned experiment with Brazilian participation. I would say that GRAND is a little bit farther ahead in time than the other experiments that we are presenting, like Auger and CTA, since we are still developing the first prototypes. But it's a very promising observatory that will probably be a game changer for the whole field of astroparticle physics, in the sense that it's relatively cheap and it will cover a very large area and complement other existing facilities. Next slide, please. So essentially, this is the science goal of GRAND. At the early stages, so with the prototypes that I'll describe later, we can already do some science, including radio astronomy and cosmology, namely fast radio bursts and giant radio pulses. Radio astronomy in general, and also cosmology, it's possible to study using the antennas of GRAND, the epoch of reionization, for example. But the primary goal of GRAND is really to do high-energy astroparticle physics, connecting neutrinos, high-energy gamma rays, and ultra-high-energy cosmic rays. So at the intermediate stages, with the prototypes of medium size, we'll be able to do some ultra-high-energy cosmic ray physics, not with statistics as high as Auger, for example, but with some reasonable statistics, so that we can gauge our experiment for the future stages. And we are also interested in doing EV neutrino astronomy and study GZK neutrinos, so cosmogenic neutrinos produced via interactions of ultra-high energy cosmic rays with pervasive photon fields. We can also do some fundamental physics, including neutrino physics, doing studies of Lorentz invariance violation, for example, beyond standard model physics in general, which is possible with such experiments with very long baselines. Next slide. So the whole idea of the primary goals of GRAND can be understood by analyzing this plot. This plot essentially shows a cosmic ray source, a very high energy source of particles, which emits very high energy, ultra high energy cosmic rays, and the interaction of these ultra high energy cosmic rays with the pervasive photon fields of the cosmic microwave background and the extragalactic background light, the EBL, it produces fluxes of gamma rays and neutrinos. So these gamma rays, they may be detected, for example, with the CTA that was described in the previous talk, and neutrinos. And we are particularly interested in these neutrinos because these neutrinos, if they are produced relatively close to the sources of the ultra high energy cosmic rays, they probably point to the direction of the ultra high energy cosmic ray production. And together with neutrinos produced directly in the source, we might be able to trace the sources of the highest energy particles in the universe, which is still, as you probably know, an open issue. So in this plot here, it's very dense, but as you can see, the ultra high energy cosmic rays, they are bent by the intervening magnetic fields in galactic and extragalactic space, whereas the gamma rays, they cascade in the intergalactic medium, but the neutrinos, they just travel unimpeded. Therefore, they can bring information from very distant sources. And we can also use gravitational waves to complement this information within a multi-messenger framework. Moving on to the next slide, please. Okay, so the science case of GRAND, one of the main science cases is ultra high energy particles. As you can see in the left plot, this left plot shows the predictions for a cosmogenic neutrino. So cosmogenic neutrinos are the neutrinos produced during the interactions of ultra high energy cosmic rays with the pervasive photon fields, as I described in the previous slide. And as you can see, this flux is very low. It's much lower than what IceCube can see, for example. And if we make a simple estimate based on the observations of Auger, we can predict what are the fluxes. So the pessimistic case for cosmogenic neutrinos, as shown in this left plot. And we can see that the integrated flux of the full GRAND project, like when it's complete, can reach such sensitivities. So we can reach this very low flux region. Therefore, that's why I said in the beginning that GRAND has the potential to be a game changer for the whole field. In the right-hand side plot, we can see the source neutrinos. So the neutrinos produced via the interactions of high energy cosmic rays with the envelope around the objects, around AGNs, for example. And of course, you have to compare these two fluxes depending on the level of cosmogenic neutrino flux. If it's very low, we'll essentially see a lot of source neutrinos, and GRAND will work mostly as a neutrino telescope. But if the cosmogenic neutrino flux is slightly higher than anticipated, comparable with the source neutrino flux, then we might be detecting a lot of cosmogenic neutrinos, which might act effectively as a background for neutrino astronomy measurements. So next slide, please. This is essentially the detection principle. GRAND is based on radio detection of air showers. So in this case, you can see coming from the top, from the upper part of the figure, you can see a cosmic ray impinging the atmosphere and producing an extensive air shower. There is radio emission there in the frequency of maybe tens to hundreds of megahertz. But Earth skimming neutrinos can also interact, producing taus, whose decay produce radio emission that are detectable with the radio antennas of GRAND. Next slide, please. So this plot here is useful to compare what are the exposures of Auger telescope array and GRAND. So as you can see, we are talking about maybe a factor 8 or so, depending on the declination band, compared to Auger and TA. But of course, this is for the whole GRAND project with 200,000 antennas. So this is very ambitious, and we are maybe a few decades away from having such an observatory. And you can see that GRAND performs relatively well. in some specific declination bands. But of course, this figure here that you are seeing, it will change a lot with time because as I'll mention maybe in the next slide or so, GRAND will be composed of several subarrays. So the first prototype of GRAND is GRAND Proto 35, which is already deployed. We have several antennas. It's deployed in China at the moment, and we are producing antennas for GRAND Proto 300, which consists of 300 antennas. The main scientific goal of GRAND Proto 300 is to do essentially just some calibrations for the next stages. And by using this array of about 300 antennas, we can study cosmic rays mostly in the energy range between 10 to the 16 and 10 to the 18.5 electron volts, more or less. There is some overlap with Auger there, with the lower energy part of Auger, and with Cascade Grande, for example. So GRAND Proto 300 is doing science in this region. And the main goal essentially is to calibrate the detectors and improve the techniques. That's why the idea in GRAND Proto 300 is to have 300 antennas plus muon detectors close to these antennas so that we can make cross checks and we can try to calibrate the antennas using a self-trigger method. And with GRAND Proto 300, we can also do some cosmology, for example, as I mentioned in the beginning, including the epoch of reionization. But the main goal, I think, is to do the transition between galactic and extragalactic cosmic rays. Next slide. Okay, so this is just some simulation studies that we have done for GRAND Proto 300. And as you can see, we expect a very large number of events to be detected, even with this relatively small array, so that we can do some decent physics. Of course, I wouldn't say that it's as large as Auger at the moment, but it's not the goal. We are just aiming towards something larger. Next slide. Yeah, so this is the timeline for GRAND. In the beginning, Federico was presenting all the experiments from this from the Astro part of this workshop. And he mentioned that GRAND and also the costs, but I should mention that, for example, this first stage of GRAND, it's completely funded by mostly by China. Most of the funds are coming from China and from France and from the Netherlands. And this stage will definitely happen regardless of funding. We have all the funds raised already, so we don't have to worry about that. And the next stage after GRAND Proto 300 is to build the first GRAND, what we call GRAND 10K, which is 10,000 antennas, which is one subarray. And then we'll just replicate this GRAND 10K in several spots around Earth so that we can cover the full sky. So the idea is really to aim for a very large distributed detector comprised of many subarrays. And the costs of GRAND, maybe I should mention, at this stage, it's completely covered, at least until GRAND Proto 300. But if everything goes well, and if we do as well as we anticipate, and if we prove the principle that we can do a self-trigger detection of air showers using a radio only as a standalone detection technique, then we will move on to GRAND 10K. And I expect that by this time, which will probably be at the end of this decade, here it says 2025, but I seriously doubt it. I would say maybe 2030, maybe we're a decade away from that. At this stage, more countries would probably join. And with the first subarray of 10,000 antennas ready, we can just start replicating this subarray around the world. So this will be a relatively straightforward process after we reach GRAND 10K, which is the hardest part to get to. And moving on to the next slide, which is my last. So the whole idea of GRAND is to have 200,000 antennas split in 10 or 20 or something like that subarrays, covering a very large area, including, of course, the whole sky. If everything goes as planned, we expect to have it done by mid-2030. So we are talking about maybe between 1 and 2 decades. It's quite in the quite distant future. And yeah, we are aiming for radio detection because it's a relatively cheap technique compared to all the other techniques that we have around. So it's relatively cheap to deploy antennas. And the science is very broad, from cosmology to fundamental physics, neutrino physics, and of course, multi-messenger astrophysics. And as I said, Grand Proto 300 will be the pathfinder for Grand. And it has a well-defined science case of its own, including cosmology and in particular the transition between galactic and extragalactic cosmic rays. And we expect to start taking data in the near future after, because we are not, Grand Proto 300 is not ready. The antennas are being produced, but we are still selecting the site because we are having some problems finding the best site with low noise. And that's what I had to say. Thank you.
Thank you very much, Rafael. Okay, so before this, we now have the discussion session on all the Astro presentations. Let me just remind you that we had the SWIGO presentation on Monday by Ulises. That was one of the other projects that Federico discussed. So Federico, the floor is yours for the discussion session.
Okay, thank you all the speakers and for the very interesting talks. So as I told at the beginning, I think we have very nice opportunity in the region for host Astro-related large project. And as you have seen in the presentations, this is quite an advantage of our region. And I think this is a very strategic thing that we have to bear in mind in this forum. As you see, I also, something I forgot to say in my presentation, it's also all the things that we have to cover and to discuss in this forum. Mainly is summarizing two things regarding, for example, the CTA project and which is highlighted in the white paper and also in the presentation. In 10 years, for example, when Brazil jumped into the CTA project, they passed through being 3 members at the beginning to be around 16 members right now, very active in the project, covering and having responsibilities inside the project. And on top of this, they also, as Vitor showed, contribute in the technology with products and part of the detector completely really built in our region. And this is something that it's very important, and also because it's something that we can easily, between brackets, sell to the funding energy, which we have to request to whom we have to request the money, so let's go back. So I would like to now to open the discussion to all the things, to the other person that would like to comment on what you have seen, heard, opinion, about the things that we have covered in this session. I cannot see the participants. Wait for a second here. Okay, I see many raised hands, so let's start. I don't see the order, So very sorry for that. I see Ivan, Elizabeth, and Jorge. So let's start in the order of the presentations. So let's start with Elizabeth, please.
Oh, yes, we have had several interesting talks, and I would like to make a specific question to Rafael about grant. I mean, it's a naive question, of course, but it is a project that's essentially based on radio detectors, right? So is there any possibility of reconcile these observations with existing radio telescope facilities all over the world? I mean, SKA, VLBI, things like that, because I'd like to understand what is exactly the difference or the band sensitivity in grant that would not allow to use or to try to use at least partially those existing facilities on radio astronomy. Can you explain this, Rafael? It's just a naive question based on my ignorance about grant.
No, yeah, this is a good question. So first, the frequency is not necessarily the same. There are some existing facilities with overlapping frequency, but we expect that for air showers at these energies, the radio emission peaks at around between 50 and 200 megahertz, and depending on where you are in this energy part, you get very nicely the signal of the air shower. But one of the main things for GRAND in particular is that we are looking at Earth skimming neutrinos with very high zenith angle, so between like 80 and 90. So particles that are coming from very close to the horizon, and in particular tau neutrinos. And these tau neutrinos, they are essentially very close to the horizon, and they are producing tau leptons which decay, and that's what we detect. So that's the first thing. We are looking horizontally mostly, not for Grand Proto 300 because that's mostly for calibration, but for the future Grand itself, we are looking at horizontal showers mostly. So frequency, angular dependence, and of course the spacing of the antennas. I'm not a specialist in radio astronomy, so I'm not sure how does the existing facilities work. But the antennas, the spacing of the grand antennas, they are chosen in such a way that we can capture the air shower and reconstruct it, its whole profile, and really make a two-dimensional drawing of the emission of the air shower. That's why we cannot use, for example, a single dish for radio detection, because we are talking about longer, much larger distances.
Right. Mm-hmm. Oh, okay. Thanks, Rafael. I was thinking also about Arecibo, but you know, the wave band has to be checked anyways, but Arecibo, you know, it's a huge one that is on the ground, is fixed on the ground. And but anyways, this is something that eventually might be checked for the wave bands, the existing facilities that are in the same wave band, because eventually there might be, you know, sub-used instruments, even in Latin America, right?
Yeah, but I'm not sure, but I don't think there is a single facility that covers an area of hundreds of square kilometers like we need to reconstruct these high energy air showers.
No. Yeah, so this has to be combined, you know. Well, I mean, interferometrically you can, but again, it's another technology. I mean, because it's interferometry of combining signals of different antennas through a continent or through the world. SKA will have several subarrays spread in different parts of the world. But again, as you said, the wave band and the inclination, all this stuff. But yeah, it's interesting, definitely. Thanks.
If I can add just a short comment, they are completely different instruments, Elizabeth. It's absolutely not possible to follow in the line of your suggestions because of the wavelengths, the polarization that has to be measured. The antennas used to measure cosmic ray showers, they look pretty much like the old antennas we had for TV at home, and nothing like the radio telescopes to make radio astronomy.
Oh, okay. But even though we have several like those, spread in the world, and some of these facilities are sub-used, mainly in Latin America. But again, of course, this depends on wave bands and other other properties that Rafael described. But yeah, it's interesting though. Thanks, guys, for the clarification.
May I add a question before going on to Rafael in regarding the possibility for grant to come to Latin America in the later stage, in the subarray stage? Have you an idea where the site could be? The requirements are very strong or not, or can you comment a little bit on this?
Yes, at the moment, I can say that it's not clear, but a suitable site would, in principle, be near Auger, so in the Andes region, because Auger has been there. There is also Auger Zaera, which is also detecting radio emission from air showers. So there is a lot of studies in that region. The background is relatively well known, and it's reasonable. It's not as good as China, but yeah, for the later stages, it would probably be okay in Argentina or Chile, but this hasn't been discussed in details so far. What we have discussed in the early stages, we mentioned a few possible hotspots for the subarrays, which include, of course, China, because China is spearheading the project, Australia, South Africa, somewhere in the States, but I'm not sure. That would have to be checked because of the radio background, and the Auger region. That for sure has been discussed.
Okay, thank you. And the antenna, the antenna itself are built in China or are built elsewhere?
No, the antenna, it's built partly in collaboration between Netherlands and China at the moment.
Okay, thank you very much.
But the funding is fully Chinese, so
okay,
for the antennas.
Okay, thank you very much. So let's move to Ivan, that has his hand raised, and then to Jorge.
Thank you, Fede. I want to address again the discussion that we were having this week in different moments. If you can go to slide 10 and 11 of your presentation, that was a wonderful presentation. And I want to emphasize this point. So we have to, the cost per project and the number of Latin American countries involved in each project. Of course, LAGO has a lot of countries and institutions, and it costs very little compared to the others. But I want to emphasize the point that you made, that we need to get more countries involved in the big projects also. So it's not just the thing that we in LAGO we need to increase our budget, but also the other it is very important that the other projects have more countries involved in their development. So for that, it's just throwing the subject to the table and for the discussion, nothing more.
Okay. Yes, more or less this was the idea of this exercise. In our view, we think going, let's say, from the project that will happen first to what to the ones that may happen in a later stage, and the one that Okay, we have Auger, which is already running. Then we have CTA, which is very close by in time, let's say. And then we have probably Swigo, and after that, maybe also Grand. But the closest one, which is going to happen, not already happening, going to happen, is CTA. And I think, as you say, that it's a huge opportunity for our region, having this wonderful experiment very close by, and thinking in LAGO, which, as you said, has a very strong impact in developing groups in the Astro field all over our region, with very low budget, also because the technology used is very is affordable for the countries, even though there are, as you mentioned, many difficulties in managing the project at a wall within our region. So this formation of human resources, for example, by LAGO, can may think as a seed for them feeding the participation in a huge development as it is CTA. So more or less this was the idea to show this pies.
Because there is also a kind of feedback loop. So if you have countries involved in some big project, they get involved in another projects, and there is people like working in different things, and this feed all the projects. So I'm thinking in something like that.
Yes, then there is also the difficulty of, which is a practice difficulty we have on how to deal with the cooperation, especially how to manage really the money in projects that are in where many countries are participating. So there are practical issues that also have to be we have to have in mind when we discuss this kind of thing. But okay, I will stop talking and I will pass to Jorge, please.
Hi, Federico. Thank you. It's regarding to what you've said, that this region is unique for this kind of experiments. All very nice, like the ones that been showing today. And one thing that it's also I didn't hear that was mentioned that make this region very special is the South Atlantic anomaly, magnetic anomaly, that it's over us, and that it's shields to the particles that it's coming, mostly the low energy particles, and we have a big hole over here, and so that they have a lot of implications, and it's getting weaker and weaker every year, and so and they can affect the society, and so this is one of the things that we have to monitor and study more. And I didn't see in any presentation that it's only in the LAGO presentation that it's related to space weather maybe. And so just to recall the attention, these are very nice projects, scientific, interesting, but at the same time, we must not forget about our relation to society and what they expect from us. And so we have to give them some answers about the specific topics. Is this related with the health of the population, for example? Is this regarding to well, any other aspect, for example, with the grid, that it can be affected by them? So of course, it's much more related to space weather, but I don't know our relation, or will we be disconnected with the space weather itself or not? Just to call the attention about this issue that it's happening now, and maybe we should give a little more attention to that kind of things, just like that.
Okay, thank you very much, Jorge. Just before passing through Carola and Vitor, Yes, and the relation to society, we also have to say that is on one side can be related directly to the scientific, to the topic that we are studying, as you mentioned, Jorge, but also the relation to society. It's when you host a large project can also from other uh, lines, let's say. So the connectivity of the place where you install a huge project is completely renew when and this is has a lot of impact in the with the society that is hosting this place. So it's the relation with the society is many parameter, has many inputs from many sides, and this is something we need to stress. But yes, also from the topic of study, as you mentioned. Thank you. So okay, so I have Carola, please. Carola, are you there? I see your hands
Yes,
raised.
I am here. Sorry,
Thank you.
the
Then
microphone did not work
okay.
properly. I just wanted to, well, thank you, Fede, first. I just wanted to compliment something that Rafael said when he mentioned and when he answered the question of Betty about installing some subarray of ground in South America. What we cannot forget is the privilege that we have with having the Andes in South America. If you are interested in Earth scheming neutrinos, you are very fortunate to have large high mountains and quantity of matter to be traversed so that you have the better detection of Earth scheming neutrinos. This is, we can take advantage of our topology and of our geography in South America. The Andes have been supporting astroparticle physics for many decades now, since the first experiments in Chacaltaya. Don't forget that. So it's very in the history of cosmic rays and other astroparticle experiments in South America. This has, they have a big role in our experiments. Thank you.
Thank you, Carola. Yes, we may say that the Andes are our backbones in many sense. Without which, will be very difficult to run. Okay, so let's move to Vitor that has a comment. Please, Vitor.
Yes, thanks, Fede. Just like to comment in the question about the South Atlantic anomaly. You probably didn't see any comment to that in the slides because the experiments we were working in the highest energies, they have absolutely no effect of the Atlantic anomaly. So the energies of the particles studied by CTA, Auger, and even Grand, SWIGO is going to be orders of magnitude above than any effect of the Earth's magnetic field could influence. So this is the first point. And I understand the worry about developing towards society and so on. And I also agree with that. However, I would like to emphasize that according to what Federico showed, we are also in a good position regarding that. Even with experiments that do not have a direct connection. If you visit the site of the Pierre Auger Observatory in Argentina, and if you understand the history of the seat where the experiment is, you are going to see an example, a very good example of the social impact of a fundamental physics experiment can have in a seat, in a region, as I can say. As I showed in my slides too, and other presentations show it too, we have instruments being developed with standard companies here in Brazil, since the Pierre-Roger Observatory, and now also with CTA, that involve dozens of engineers and dozens of workers of factories, as I showed the person welding a part of a telescope here in Brazil. I think this is a huge social impact that our experiments have had and is having in our society, even if it's not the direct target of our science. I think we are in a very good situation about that.
Yes, thank you, Vitor. I completely agree with your words. Okay, so let me see if there are more raised hands.
I cannot raise my hand, but I have a question.
Okay, please, Rogerio.
And I don't know who can answer this, but it seems to me that CTA and SWIGO have some similar physics in terms of gamma rays. So I wonder if there is a comparison, because I've seen plots comparing, for instance, Vitor and Elizabeth also showed plots comparing CTA with HAWK. Is there a plot comparing CTA with SWIGO?
Yes, they started to be done now, Rogerio, in different fields. Indeed, we just published a paper comparing the dark matter possibilities of CTA and SWGO. And a more general answer to your question is that SWGO is aimed in energies a little bit higher than CTA. The sensitivity is going to be better of CTA only at hundreds of TeV. But not only that, the sensitivity is a different energy range. The operational way of both experiments is also different. CTA points to a source and has to choose the targets and study each target in a different moment. These wide field of view experiments like HAWK and SWGO is going to be, they are looking upwards and they integrate in the whole sky. So they are complementary for different things. So CTA can make a deep study of thousands of sources, but the wide field of view experiments, they can have a very good sensitivity of the full sky, not needing to point anywhere.
Thank you, Victor.
I would like to add a comment on this as well, because yeah, you in this slide that you are showing with the ASTRI mini array, Federico, it has a diagram that compares not CTA but ASTRI mini array with these experiments and coming ones, right? And there are two experiments here that are of the same kind, are of the same sort of SWGO. And as Vitor said, they will be complementary at the highest energies, CTA and LAGO and also HAWK. And SWGO will do essentially the same, will cover the same as LAGO, not LAGO, but HAWK, but in the south, right? But yes, the advantage with the CTA and the ASTRI mini array is that you will be able to solve these sources. And while a HAWK essentially gets the flux, right? But it cannot really solve point sources. So ASTRI mini array will be already ready to do this, doable. It's going to be doable with ASTRI for the highest energies. That is exactly the region of sensitivity of HAWK, and in the future SWGO. So they are really complementary experiments, both CTA, ASTRI, and these tank-based experiments like HAWK, SWGO, and in the future LAGO as well. That is another facility of the same nature that is being developed mainly by Chinese and in Asia. It's just a comment on this.
Thank you, Betty.
Okay, thank you very much. Adrian is.
Yeah, thank you.
Just one thing also, I think, if I'm not wrong, that Ulises on some of the session early in this week showed the
it was on Monday. He showed on Monday the sensitivity course.
Yes.
And I must say, at the very end of the highest energies, Swigo is going to be more sensitive than any other one in the south. It is true that the point resolution it will be lower than ASTRI or CTA, but the collection area or the exposure will be much higher. And regarding the space weather studies, Swigo is going to have also have a branch, scientific branch, doing that, as is done for Auger, for example, having tanks. And I don't know if that, I'm not an expert on that, but I don't know if that is related particularly with the anomaly, but the space weather subject is included in Swigo. And just like that. Thank you.
Okay, thank you very much, Adrian. Let me see if there are raised hands. I don't know if there are some questions in the Slack channel. I cannot see it right now. So if somebody may tell me if there are questions there. And okay, it's something I would like to stress related to some discussion we had the other day raised by Marcela on particularly on we have to also bear in mind what we have right now, what we will have in the near future, and what we would like to have as a strategy line in the most distant future. I think that the astro field in all its variety has really a high opportunity to be the starting point for tracing a pine lines toward a more broad strategy of the region, and probably what we have learned in all these years running this the experiment that are already running and projecting and constructing those that are close to be finished, we may spot the strengths and also the weak points of our region. So we really have to pay very much attention in how the process of all these projects were in the timeline, and try to focus on the things that we can improve for as a region, and this is something I would like to all of us to bear in mind, and thinking in concrete things we may push, and we may ask to our agency, to our politics, in order to not repeat things that we know that then make things more difficult, and to try to foster those that are we did well in the past. So this is something I want to say. If there is any other comment, question to the presenters? Rogelio, you have always a question.
I already asked it.
Okay.
Okay, Federico, if there are no more questions or contributions, we are running a slightly over time. We would then have a break. We'll be back at 8. What time is it in Sao Paulo? What time is it there, Rogerio?
It's 10 to 1.
10 to 1. So we stop for 15 minutes and we back 1:05 to continue with the next part.
Okay. Thank you very much to everybody.
Thank you.
Bye.
Goodbye. Rogerio, can you hear me?
Thank you. Bye.
I can hear you, Claudio.
So my slides will be
All right. Well, everyone, we're going to restart. So now the next thing on the agenda, we're going to have an update about Snowmass from Claudio Deeb, who's the LA representative to the Snowmass Advisory Group. Claudio, please go ahead.
Thank you, Marta. I don't know, can you hear me? Yes, okay. So I want to thank the organizers for this invitation. I was recently nominated as a LA representative to the Snowmass Advisory Group. And so I want to give you a brief description of what Snowmass is and what's the current status. Next slide, please. So what is Snowmass? Formally, Snowmass is the particle physics community planning exercise organized by the Division of Particles and Fields of the American Physical Society. It's a long-term planning exercise for the high energy physics community in the United States. Its goal is to identify and document a vision for the future of particle physics in the US and its international partners. And then it will communicate the opportunities for discovery in particle physics to the broader community and to the US government and its agencies. The Snowmass summer studies started in 1982, organized with the help of DPF at Snowmass, Colorado. Snowmass actually is a ski resort near Aspen, but this is meetings in the summer. And it was followed by similar summer studies in 1984, 1986, 88, 1990, and so on. The Snowmass summer studies, organized by the community of particle physicists, not by one national laboratory or its users, or not by a funding agency, has served as a unifying forum. So you see the parallel to what we're doing. They bring together theorists, experimenters, accelerators, scientists, working in the United States and abroad at various research facilities, universities, and national labs. At the summer studies, the physicists debate what is being done in research and what priorities they assign. They educate each other and build essential consensus for the pursuit of common goals. So the strategic planning goes as follows. Snowmass, which is a community-wide exercise, takes about a year, and then they document their conclusions and they make a report that is submitted to the so-called P5, which is the Particle Physics Project Prioritization Panel, which is a sub-panel of HECAP. HECAP is the High Energy Physics Advisory Panel for the DOE and NSF, which are the main funding agencies of particle physics in the United States. And with that, they formulate a 10-year plan with a 20-year vision within their funding constraints they have. Next, please. So let me go to the previous one, Snowmass 2013. There was a Snowmass planning meeting at Fermilab in October 2012. There were several frontier workshops done in different places. And it's emphasized that it's in different places because they really want to gather the opinion of the whole community. It's a diverse and inclusive process. Then there is this Snowmass summer study that was in Minnesota in July 2013. And from then on, they have to write the report, and the Snowmass report was done December 2013, and that was given to P5. It was a very successful process. Next slide, please. So from Snowmass, they gave the report to P5. The Snowmass 2013 report had put 3 frontiers in research, which is the energy frontier, the intensity frontier, and the cosmic frontier, together with some cross-cutting research areas, which are facilities, underground and accelerator, instrumentation, computing, theory, communication. And then the P5 2014 report, they came up with 5 science drivers from the previous report, which are the following. And you can pretty much see this was happened before, and you can already see the effects of this. First, to use the Higgs boson as a tool for discovery. Second, to pursue the physics associated with neutrino mass. Third, to identify new physics of dark matter. Fourth, to understand the cosmic acceleration. And five, to explore the unknown. But obviously, all the other 4 points are also exploring the unknown. This is probably to explore the really unknown, new particles, interactions, and principles not included in the previous science drivers. Next, please. So here you see more or less the timeline and where we're standing now. So the execution plan begins like in 2015 until 2025. So it's a 10-year plan. And then the next round will be from 2025 to 35. And we're kind of like in the middle of this 10-year plan. Next slide, please. Here you see the particle physics planning processes in Europe and the United States. So in Europe, the frequency is about 7 years. In the United States, about 8 years. The process takes about 2 years. So it's 1 year of science done by the community, which in the United States is the Snowmass. And then 1 year priorities done by the panels like P5. Next slide, please. So now let's go to Snowmass 2021. So based on the success of the previous one, with all the lessons learned, they came up with 10 frontiers. The energy frontier, the neutrino frontier, the rare processes and precision measurement frontier, the cosmic frontier, the theory frontier, accelerator frontier, instrumentation frontier, computational frontier, underground facilities and infrastructure frontier, and the community engagement frontier. Next slide, please. So now the organization is as follows. There is the main driving force here is the steering group, which is formed by the Division of Particle Physics Executive Committee, plus a representative of the other divisions like Astro Physics, the Division of Physics of Beings, the Division of Nuclear Physics, and the Division of Gravitational Physics. And then we have the 10 frontier conveners. For each frontier, there's a convener, and there's a co-convener, and they are divided in topical groups, also with the conveners themselves. And then there is the advisory group formed by the steering group that I just mentioned, plus the rest of the DPF Executive Committee, which are members at large, secretary, treasurer, and counselor. There's also an editor and a communication liaison. Oh, there's a misspelling of communication there. It's one T. And then there's an international team of advisors, one from Africa and the Middle East, from Asia Pacific, from Canada, from Europe, and Latin America. Next slide, please. So here's was just what I said. With the names of the people, you may recognize some of them. The chairperson of the steering group is Yang-Ki Kim. You also see Tao Han there. And at the end, the right end, last but not least, Latin America. Okay, so the steering group meets weekly. The advisory group meets once a month, and the frontier conveners, and they meet every 2 weeks, and together with the advisory group every month. Next, please. So here's the community planning process for this time. There was a kickoff virtual, in this case virtual, town hall APS April meeting. Then the teams are getting organized, the selection of the conveners is done, and the 2020 Snowmass community planning meeting will be in November. And from then on, there will be several workshops by the different frontier groups in different locations. Maybe most of them, at least this year, probably will be done virtually. And here it is stressed the importance of openness and the open international collaboration, because physics today is clearly recognized in particle physics that is global. effort. So this ends in 2021, the Snowmass summer study, which will be in the United States at the University of Washington, Seattle in July 2021. Next, please. And the written contributions of people at Snowmass, they have two forms. One is the letters of interest, which is already open for submission until August this year. It's just a 2-page of text at most and plus references. It's an informal document that is useful at first stages to help the conveners to prepare the planning meeting. Includes opinions, interests, proposals. It's a rather informal document. And then there's the contributed papers. One doesn't have to write one to have the other, independent. The contributed papers are open for submission until July 31st, 2021, which is actually a bit after the summer study. So these will be part of the Snowmass proceedings, white papers on specific scientific areas, technical articles, etc. And they will remain as part of the permanent record of Snowmass 2021. Next, please. So, well, the current activities that you may see is the planning for the meeting that will be in November. So there are already meetings of the different groups. Some of them are kickoff workshops and so forth on. There is a calendar with the activities on the web. Next, please. And the communication to the community is done with this wiki page that you may find there. And there is also a monthly Snowmass newsletter that comes. I show you there the last one, which is July. And I think that is basically all I want to say. So next, please. And interesting enough, Yankee Kim, I think right now is giving a similar presentation of Snowmass in the HECAP meeting that is taking place yesterday and today. Okay, thank you.
Thank you, Claudio, very much. Anybody has an urgent question for Claudio before we move on to the next session on next steps of our process? No, seems there are no questions, Claudio, but thank you very much once again.
Welcome.
Thanks. Okay, so we're going to start the next is part of the agenda. I'm going to share my screen, but I would like to invite all of the organizing committee to turn on their videos if they can, if possible. Okay. Can you see my screen? Yes?
Yes. Yes.
Okay. So first of all, I want to start off by thanking all of the speakers, all of the contributors, and very especially the conveners of each of the subtopics that are members of the preparatory group. I think that we've had some very interesting days and presentations, and everyone has made a big effort in this sense. I also wanted to come back to a point that was raised in one of the discussion sessions. I'm not entirely sure by whom, but it was around who are we trying to communicate this to? And I want to emphasize this point first and trying to really reiterate that, of course, this is something that we're working on as a process that we want to communicate to the rest of the physics community, to our physics community here in Latin America, but also outside of Latin America. It's a process that will allow us to have some, solid well-constructed documents that will be a reference for any physicist around the world that is interested in knowing what is going on here in the region, and what are the main activities and the strengths that are being developed in the region. It also is, of course, a document for our funding agencies or research councils. We worked very hard, of course, with Marcela and Fernando, and Xavier and Rogerio in many ways, but to get that mandate at the ministerial level was also really important. And I think we have this first time opportunity to be able to produce a result that we want to give to this joint group of ministers at the Latin American level. It doesn't mean that it's a very clear path, that we know exactly how everything's going to go. We are building this from a grassroots effort, as it said, a multinational scientific community-based effort. And it has many challenges just because of what it is. But I think that all in all, it has a very clear goal and a very clear purpose. And we have this window of opportunity that we're really trying to make the most of. So with these kind of preliminary comments, I want to highlight first some preliminary results or benefits of this process that we've already started, and that we can see in what we've been able to produce up to now. We have a first repository of initiatives and advances in the field. And this is important. I mean, we didn't have this before. We've been able to go through a deeper dive into detailed information of the majority of the experiments, initiatives, results in the region or by the region. We've also been able to increase the opportunities for discussing amongst ourselves. I think also one of the important conclusions that we are making from this meeting is recognizing the benefits of having increased mobility amongst the region in the different groups, when we've been able to now identify which are the key strengths that are distributed around the different countries and in the different institutes. I think we also have, and in particular in the last session, highlighted the strategic relevance of geographical location in Latin America for experiments in the astroparticle cosmology domain. Again, we can also see this growing insertion into flagship international projects at the global scale by the different groups in the region. Again, I want to highlight the identification of key strengths and contributions in instrumentation, computing, software, in particular groups. It is clear that it's not homogeneous in the different countries in the region, but we can see how those that have developed over longer periods of time have increasingly more responsibilities and more technological contributions to the different experiments. I think that we've also identified important regional training programs that can be built upon for future strengths, and an enhancement of synergies and collaborative efforts at national levels. This is made in many countries. It has been a way of looking at the national activities and trying to create national roadmaps through this process. So it has produced all of these, I think, very positive results that we can just highlight. I do think that we also can say that we have some gaps, and it's fair to say. We still need to ensure a better capture and inclusion of all relevant participation in different initiatives. We know we haven't captured all. I think we've captured most in most of the subtopics. Some are pretty well covered and some are less so, but I think we've done a pretty good job. I also think there's some gaps in the uneven results in the national mechanisms that were put in place to capture or to participate in this effort. And this is just, to take away back to each of our countries and see how we can develop a stronger process in our national mechanisms to contribute to this American effort. I think that it's still clear that their capacity building that needs to be strengthened in terms of human resources and instrumentation, software, computing competence in some countries, and for some subtopics in the region. So again, it's not homogeneous. I highlighted the strength, but also the need to continue to develop the capacity building. An issue that also came up in our discussions was the recognition or the lack of recognition of individual contributions in large collaborations. And this is not a problem limited to Latin America, but it's also something that we would like to be able to highlight when we are, presenting the results that we're developing. Also, the need to enhance the internal impact in large collaborations given by the different groups. How can we work on enhancing the impact of the different groups when they are immersed in large collaborations? And again, what we are trying to do now is to really highlight those contributions, and that they will be noticed, and that their impact will be there for everyone to see. And I think that one of the important things that is also, relevant for us to really be clear on is that we have documented now many contributions relating to existing experiments. But to build a strategy and a roadmap, we need to project more where we want to be in time and what would that participation look like. So we do have some cases, and it's very clear in some of the subtopics what is this really, and looking at a very long time scale. But in other cases, perhaps it's not so clear. In some cases, in large international collaborations that are definitely not in the region, it's clearly dominated by the global dynamics of what is going to be the next, strategic research infrastructure that's going to be developed. But I think that we do need to think about this quite a bit more. So the point is the way forward in the next few weeks in our process. I presented the timeline at the beginning of this open symposium on Monday. I'm not going to go through that again, but it's clear to us that in some cases, some of the conveners will need additional information to strengthen the physics briefing book. And we rely really on all of you as scientific contributors to produce the best result possible as a result of all of this process. And so I just want to highlight, in some cases, there's a need to gather some more information, and the conveners will reach out to you for certain information. I'm just going to highlight some of it. We do have this pretty clear in some of the contributions, but not in all. So, a real scientific brief for a particular contribution, experiment, or facility is really where it's located and the contact person that we want, what are, the very concise introduction to what the experiment is and the scientific goals. But really, in many cases, we're missing a figure of merit of the scientific driver. So we will need some concrete plot to show that figure of merit. The specific scientific results contributed by LA groups, for example, in ongoing experiments. If we want to be able to highlight the contribution of those groups to a large collaboration, we would need to know which are the particular contributions through a specific plot or the references when applicable. If we look at another dimension of the technological impact, like which is the specific LA contribution to a detector, to an instrumentation, or to software and computing, what are the major competences that the LA group has right now and that are clearly recognized? The current and foreseen Latin American involvement, the timeline and major milestones. Another aspect that was insisted quite a lot upon during these days has been the capacity building. How this is an important component of our process, that we're not always at the forefront of the scientific merit, but we are still evolving and still building capacity. And so there are technological advances that are important, that there's advanced training that's important, and the connection with industries. And these we were able to find a few very important results in this past week that were showcased. Which are the parts that are being built by local industries, and what are the new industry efforts that are led by a workforce trained in physics? The funding profile, costs and expenditure, disbursement for experiments in the region in Latin America, or for example, the expected contribution to international experiments. So yesterday we had a very clear presentation that was telling us the details about this, but we don't have it necessarily in all cases. And finally, some of the main challenges that we may be still that are still there for some of the initiatives. It could be a technological one, it could be an infrastructure one, or it could be like in the case of Andes, that it still, needs several other layers of approval at governmental level for the possibility of existence and construction in Latin America. So I don't want to spend more time, and I want to really pass it on to the rest of the organizers for their own thoughts, and to hear also more points of view from all of you. So thank you. I'm going to stop sharing right now. Thank you. So maybe Marcela, can you continue?
Yeah, sorry, my mute was not responding. I think it would be good if you share your last slide. I think that you still keep it there. I think it's good. Because I think that's something that I would like to concentrate on, that, because I think it's very important. So I guess what I would say is that if we can, so Marta, can you share the slide again? Yeah, thank you. So what I'm saying is that first of all, I think practically we want to have you all thinking that we will have from today, not more than 3 weeks, or 2 preferable, which is by the end of the month, to get input. So I think I would say this is very important for us to get this information, I think, for all the conveners. And so without, all of you know who you are and who could contribute. So I would please ask you that you review your white papers, and please think about providing the information we are asking here, so so that you don't wait a week until we contact you and then it becomes delayed, because I think we have been delayed in the past and we don't have that luxury now if we want to say something for on time to the high level strategic group. So I think that in my opinion, I already said that we are, of course, starting here. Claudio was just telling us what the Snowmass process is. And, we are trying to not invent the wheel, but copy a bit what has been done in the European strategy and what has been done in US or Canada in the past. But of course, we have to do it in the way that fits to Latin America. And as we saw, there are many different levels in Latin America. And so we want to, some of them are much more developed because the opportunities are much better for Latin American communities, correct, for Latin American scientists. And the only thing I wanted to say is, so first again, reiterate, please look at this slide, please think what you can give us that is not there in your white papers and is what we are asking here. I think this is my number one ask in the name of every convener. And second, I think that thinking what Jorge and others ask, I think that training capabilities and what is there, like, going from training capabilities at all levels, including the starting new industries that are led by workforce training physics, as I think Claudio was mentioning at some point in the discussions. I think this is something that is the best we can sell to our funding agencies and to the society, to the government, correct? That is really something that will come back to society in infinite ways that we cannot see. So I think I will pass the baton to Rogerio or Fernando or Xavier. Xavier says that he cannot really have a video because it's awful connection. Maybe Xavier can tell us a bit about the idea of the group we are trying to form at some point for thinking about underrepresented minorities of all types in our field. that we have discussed a bit offline, and at some point would be good that that we share it with you to hear the opinion of the rest.
So can I mean, I thought that we could do in the real final 5 minutes closing. I don't want to deviate from this.
Yeah, no, that's right. Yeah.
So if, I don't know, Xavier, if you want to talk about this part, we can then come back to the other issue afterwards.
Well, I prefer to keep my word at the end and focus on the other topics. So, I mean, from the what you and Marcela said, I just fully agree. I mean, not much more to add.
Okay, thank you. Rogerio.
Well, this has been an incredible experience. We're learning on the fly, basically. Of course, things are not perfect, and so we need input to make things better. But this is a starting point. I think this is a very good starting point. I think we're being successful in getting together the community in Latin America for energy physics and cosmology. Now, yes, we have those 40 white papers that were contributed, and we may need some more information to write the briefing book, physics briefing book. And yeah, so these are the points that we're going to probably go after the contact person. It's important to have a contact person, that's for sure. People that we can ask for information. I think, if I'm not mistaken, Marta, we're first approximation speakers will be the contact points for each white papers, correct?
Yes, correct.
But there could be changes, so please let us know if there are any changes.
I would add one little comment there, Rogerio, that
yes.
is these contact persons, but I think that my little experience with European strategy, you know, especially many young people or not so young people, everybody's more or less young in my perspective, who have contributed, who made a plot, who, you know, we needed to highlight something and they really worked. I think it's important to tell to this audience that those who contribute will be listed as special contributors. Of course, the white papers will be listed, all of them, in some appendix, so that everybody who contributed to a white paper, their members could be there. But we will need, you know, someone to help concretely in, you know, making a plot, making a table that we, you know, tables or plots, we put plots there, but figures or tables that show things, correct? And I think that this is up to the conveners, of course, but I think that when we think that someone has made a significant contribution, we will have in the briefing book a place where we say significant contributors to the briefing book. Because I think, especially for young people, it's very important to be recognized for their work.
Yeah.
Thank you. Claudio, do you want to say something?
Yeah, something very briefly. I mean, as you may have noticed, that there were no contributions from Chile. And this is not that because nobody's doing anything here, but there was a problem, actually. Was a political, you know, uprising, and that disturbed the whole community. And so there was nobody who would be able to write this on time. But there are many things that have been done here. There's, of course, the Atlas participation. We are now building components for the Atlas upgrade. The number of institutions grew too. They are forming groups in different places now, even away from Santiago, which Chile is a very centralized country, and this is very good because it means that inclusion of the whole community. And there's some even issues of building, say, mirrors for high energy physics experiments together with astronomy. So there are some things are catching up, and probably they're not represented from what I see. But that's just to keep in mind.
May I answer?
Yeah. Yes, go ahead, Marcela.
Sorry, I don't know if everybody will agree with this, but what we have in the slide now is a way of, you know, has to be something that is, I don't know, 2 pages, the answer that we can get for this, if someone wants to put information. And normally, of course, you know, again, I would say thinking in parallel to the European strategy, you know, there were a couple of situations where people came with something late. And so there was, you know, now everybody who did a white paper will try to kind of fill this 2-page, it's not a questionnaire, this 2-page request that we are putting here on the web, correct? And maybe Marta can go more. So I think that if you, as you know, the Chilean and LA representative, just Snowmass, but as Chilean representative in some ways here, I know there are other people from Chile, but feel that is very important omissions have been made, and you can organize to that we get, you know, not more than a handful, I guess, of input in this format. I think the conveners can decide if they can consider it, which I hope the answer would be yes. That's what I think, but someone may disagree. So
no,
that's
I mean, I just want to reiterate, I mean, this kind of information was the one without the red part is very similar to what we asked for when we asked for the first 18 scientific briefs at the beginning of the process. And there were two pagers. Those are important, it has important information, is different from the white papers. So anyone that would like to contribute, we would like to have it. I mean, it will be up to the conveners to see what is included, but we can always post that information in the ASTRI website. So I think that is always useful. And we're doing this for the first time, and you also recognize, even in when you were recounting the Snowmass process in the U.S., Claudio, you showed how the time between the different events, you know, became, you know, longer. Once they started, at the beginning was much more frequent, because I mean, it's just a process to get this really going. It's not as simple. It takes a big effort, and it also we need everybody to become more convinced of the value of going through this process. Fernando?
Yes, let me see, do I have yes, I have. No, I just wanted to congratulate everybody for all this big effort, and I fully agree with the presentation of Marta and the words of Marcela and Rogerio and Xavier. So for me, just wanted to add things like that from the high-level strategic group. I have been very impressed how seriously they are taking this initiative, and so far they have been very impressed with the response and the quality of how it's being organized and the quality of the proposals. So I think this is a good timing for us to show that Latin America can be on the map with serious and also very mature the society. So in that sense, it's good that this is moving on. And but of course, this is only the beginning, and we have several deadlines here. I have been checking on the timeline that we have. So I think that there will be a lot of work now filling up this and going to the preparatory group and filling up the document. And then the high-level strategic group, we're planning to meet 2 or 3 times before the end of the year. So I urge you to have to work as hard as possible to have to be able to follow with the time frame we have established, which I think is realistic. And yes, I don't think I have to add more.
Okay, thank you. So anyone, Rogerio, go ahead.
Just something, just since Claudio is here and he presented this thing about the Snowmass, something we discussed. I think it's good to tell people that we're discussing within the preparatory group to submit a letter of intent to the Snowmass process for Latin America. I think that's
yeah. So
something good to do.
Yeah, I think that this is really important. It would be the first time that, you know, as a region, a contribution would be sent to one of these processes. Snowmass, as I mentioned before, when in my presentation, Young Ki, when she was presenting at the Granada Symposium, she reached out to several of us here in Latin America, and we put together presentation for her to explain what we were doing, why, what was going on here. And she included that in her slides because she had been asked to report on the Americas in general. Also, I mean, with this level of, of development of what we're trying to go through, perhaps we'll be invited on our own next time to the European strategy instead of included in just the Americas, and as we are now in the Snowmass process. So I think that it gives us a different level of visibility, which is important. And this is one of the things that we want to do. And so it comes back to the point of what I was saying at the beginning of who do we want to communicate this to? We communicate to of course, to our own physics communities, but outside of Latin America as well in a very significant way. So any questions?
Or comments or ideas? There
was a comment on Slack about project management capabilities in LA for big projects. Maybe I can just comment a thing on that. It's something which is difficult to find even outside LA. I mean, quite a few projects and even some projects from the US or from Europe have really not that good project management, I would say. So it's not easy to find good project management. That's probably something we could actually share. In Auger, we have a great experience with that. So we've been running for 20 years. We've had 10 years of planning before that. And we've had project managers initially from Fermilab, and now the current.
We lost him.
We lost him, yeah.
We lost him, unfortunately. Maybe we wait that he comes back, and I think there are 3 hands up, Marta, Dewis.
Yeah, one thing just before that, I mean, this form that's here, we will put it on the last free website, and then you can just download it from there. So it will be there and it'll be available. And you can look at the original scientific briefs that were requested that give you an idea also of how to do this. Sorry, Davis?
Yeah, hi, thank you. So yeah, first of all, thank you for the organization of this conference. I think it's very impressive that you can join this different physical aspects and different experiments, topics, in order to have a common strategy. I just want to come again with this point that I said some days ago related with something that I am very interested is in the technology, in general, the transfer of technology to the industry. But something that I think that can help in to organize that is, I see for the different presentation that there are already some experience in the past, and there are experience in different countries, universities, with the development of chips, detectors. So I think it will be nice, I mean, if we can have a compilation of all these efforts to know who is doing what. Probably there is some places where the people are doing something that we need, but we don't know. Or probably someone already did something and we can gain for the experience already gained. So obtained. So I think this is something that probably would be, for my interest, is very, very nice to try to have a compilation of that efforts currently or in the past that can help for the development of the current experiments and future experiments. So, I mean, I saw in different presentations that people say some countries have this manufacturing this, or they already did some chips. So I think it's something that we can try to combine. For me, it will be very helpful.
Right. So, I mean, first of all, of course, we have all the presentations that are available on the website. But precisely that is the part that will be included into the chapter that takes care of the detectors, instrumentation, computing, etc. I mean, that's what we're going to highlight. not of the far past. We can only do with what we have submitted, because we can't go around finding what was done before. We have the information that we've been able to put together that is the most recent, up-to-date information. I also think that is important to highlight, and I really, enjoyed very much the presentation by the Argentine group done by Fernando Monticelli, showing really the progress that they are having to now build up capacity in a very significant way, and the way they're going to be contributing in hardware in a very relevant way in the future. And so, I mean, this is again another example of how you start with something very specific, very concrete, oriented towards some things, and then you can harness your capabilities in a very interesting way to have much more impact further down the road. I know it in my own experience as well in Colombia, some of the cases. But perhaps it wasn't as highlighted in this presentation, so that's why I referred to it in the Argentine case. So Mauro?
Sorry, Marta, maybe something to think about for the community. We just heard from Daniel Elvira that there was this meeting that was about computing for HECAP. Maybe there could be, as an offspring of what we are doing here, thinking about technical developments for HECAP, and could be something that the community could organize a meeting and have presentations specifically related to this. Maybe that could be a useful direction to think about for those who are interested.
Yeah, good idea. Mauro?
Yes, can you hear me?
Yeah.
Okay, excellent. So first of all, I would like to thank the organizers and all the presenters for the nice talk and for pushing this initiative. I think it's very important. My question is, of course, I understand that in this second symposium, we were convened to focus on the physics and analyze the white papers. And from that perspective, I understand why the different representatives from funding agencies may have not been invited as it occurred in the first symposium. Mm-hmm. So my question is there any indication as to contact them, or what are the next steps to in this direction? Because in my case, as representative from my country, Chile, one of the representatives here in LASPRI, it would be interesting to know when are we supposed to contact them? If so, maybe we're not supposed to do so. I don't know. Because, of course, they are very relevant actors.
Yeah. So this is an important point, but you're absolutely right. It was a decision made by us and the organizing committee to not invite the funding agencies to this meeting, to this open symposium. We discussed this, and it was really going to be very much focused on trying to identify the key strengths in the physics and the activities that were going on in the region. So we didn't think it was the moment to do it. However, at the same time, we have been trying to maintain contact throughout with different representatives of different agencies with more or less success. But you are making precisely the relevant point, is that we need to be able to go back individually at our country level to again reiterate this message, and that they know that we're working on this, but they were there at our previous meeting, and we've maintained updates on this. But we need to go back individually and then bring them all together to update. So they are supposed to be included in the meetings that we will be inviting for the high-level strategy group, because remember, as I explained in the first session again, the three typologies of members of the high-level strategy group, and one of them are the representatives of the funding agencies. This is non-trivial, and it requires all of us to work to get them to sit there. So we need that effort made by all of us to actually get them to be present at those meetings.
And just to add one thing is that there will be a report by the high level strategy group, and so maybe Fernando can say something about that. But I'm thinking in parallel, like here in the US, there was this P5, and finally we have the P5 report, and that was used a lot and became something that agencies was, written in a way that is very friendly to non-physicists, to people that are interested in science but are non-physicists, and that could be something that will be something to refer to when you are talking to your funding agencies or to politicians, because this is something that is coming from above the actual community and is a Latin American effort, and it's a very good tool to get people that are not the scientists to buy in supporting science. So we could use, it has been very successful. This P5 report has to be written in a way that is, transparent to non-scientists, of course. But I suppose Fernando can say something about that, I'm sure.
Yes. No, definitely. Yes, on this part is totally true. But just to remind what I think Marta mentioned the first day. So officially, we were given this green light to proceed in this way as a pilot project from this ministerial meeting. So in principle, one of the targets of this report at the end is to present it to the ministers. I mean, in that whenever they meet again, it was supposed to be in October this year. We don't know if the situation will be how the situation will be. But then we also gave a presentation last year to this EU CELAC, which is this initiative between the European Union and CELAC, which is a union of Latin American countries also, that they have been independently thinking about this large-scale infrastructure initiatives, probably in covering other fields beyond high-energy physics. And I think it's important for us to keep also always in touch with them, because they have access to funding through the European Union and so on. So definitely we plan to try to bring this to all the funding agencies so that we can eventually get something from them. But it's already, the channels are already open, and the question is, once we have the material, we can just proceed. And it's important to show them that we are working together and that we have something very professionally done, such that the case becomes very strong.
Okay, Guillermo.
Hello, Marta. Thanks. Just to make a comment, just an opinion, right? So sometimes in high energy physics, right, you depend on very big projects, right, to do cutting-edge technology or science, right? So I would like to make the point that I could find a few projects that can be entirely developed in Latin America, and they don't need any strong support from other countries, right? One of them is, for example, LAGO. The other one is these low energy skipper CCD applications that we have covered. And I saw a couple of them that I don't remember now, but those are from the Argentinian side. That's why I remember them. I have them in top of my head. So I would like to understand a little bit what is your vision about trying to identify this project that can be completely supported or held in Latin America and can be fully accomplished on these countries, right, or this region.
Mm-hmm. Well, maybe I can say something. Is well, that's good. If the things can be funded locally, that's the best. It only reminded me the first time I met Xavier Bertu. He was telling me about many of the projects he had. I don't know if Xavier, you remember. And at some point, he told me about LAGO, and then he said, "Well, I'm asking you for funds for LAGO because LAGO is so cheap. I wouldn't bother to ask someone with more money." And at the end, that's very good. I mean, if we can fund it locally, so we have detectors in many small countries, and that's good to have. So, and I think self-funding thing within Latin America ideal, and many of the things will be the capacity building in many of these subjects, we can just handle ourselves with many meetings and so on.
Okay. Elisabetta? Are you there? No?
Yes, I'm here. Just I was trying to. No, Mike, I have a comment with regard to your presentation, Marta, when you discussed about the ways by which we can reach the community, physics community, not only astrophysics and cosmology community, not only in Latin America, but in the world, all. And within our own countries, we have this kind of difficulty as well, right? In communicating among the sub-communities, let's say astronomy, physics, cosmology, right? I myself come from the astrophysics community, astrophysics and cosmology community, and it's always hard, this communication among the communities, right? But I would like to emphasize that we have built in São Paulo a network that is called Astronet, and this network is intended to be a hub eventually in Latin America and also to the rest of the world, where that associates all the important projects, current important projects in astrophysics, not only, I mean, national and international efforts in this direction. And these projects are all under this umbrella of this Astronet network, right? This hub. And of course, there are several overlappings of this hub or this network with this forum that we are discussing here. So in this sense, I think it would be interesting to try to establish some sort of communication between these two initiatives, let's say. So it's, again, Astronet might be helpful to make possible this, improve this communication, right, among the communities.
Yes, so thank you so much for bringing that up. I think that's one of the things that we're also seeing, is that we have many more opportunities of interacting in different spaces. What you're mentioning is one of them. Alinka mentioned another one that was also very interesting. And so that just fostering our more in-depth conversations and connections, I think it's just for a benefit for all of us. So I agree. Thank you so much. Tere.
Yes. Hi. First of all, of course, I would like to congratulate the organizers and also all the speakers. I couldn't follow all the presentations, but I have this compilation, which is great, with all the talks, very, very good level. I think that is really important to keep the momentum. These kind of workshops are like an injection of energy. But I think that we cannot ignore that we are living in we cannot live in a bubble. We are living, we are passing through very, very difficult moments here in Latin America, in my country, Brazil, Chile, all the countries, Colombia, Venezuela, Ecuador. We cannot ignore that before we wrote the white papers, we had one situation, and now we have another situation. Mm-hmm. We cannot ignore the impact that this pandemic is going to have in our countries. And I see here, and I think it's the same everywhere else, that all the efforts from the founding agencies and the Ministry of Science and Technology and so on are now focusing on all the kind of projects that are to in fact, to fight this pandemic. So I think that we need to keep the momentum, but we need to see, we have to be aware that the situation is not the same. And we have an additional challenge to go to the ministerial meeting, because we have to convince them that still all the things we are doing are very important, and that, it's not that, otherwise it's like here sometimes if you are not doing something against COVID, then okay, you have to wait, you are not my priority. So I think it's an additional challenge we have when going to the ministerial meeting.
Yeah, I think that's a very important idea. I think it's very true. We mentioned it earlier on. We also know that we are going to have to find the ways in which we're going to be able to work around those very complicated issues. But I mean, there have been also clear reports around the world of how physicists have pivoted to contribute to the, to the governments and to the strategies for all of the problematic issues that arose because of the COVID-19. And that is something that is important, and clearly the contribution that we are doing as physicists in general, how it impacts society. We need to continue to make this point. It was raised today and maybe another day, and it's going to continue to be there. But I do think that not only we are right now with a critical public health issue, but the economic repercussions for the region are going to be very significant for the next few years, of course, for other regions as well in the world, not only in Latin America. And so our case becomes very complicated, and we are aware of it, but thank you so much for bringing it up. I mean, I think it's not something that is, we're not in a bubble, absolutely not. You're completely right. Jorge. We have three more, Jorge, Ivan, and Harold, because we're over time now.
Okay.
Jorge, please.
Okay, thank you. Going in the same line as Teresa and Mauro and Marcela were talking about, it's how do we get to the ministry for requesting the money? So I think what we are doing here, it's very unique. We have to keep the momentum, and one of the things that will be interesting for us is go with this document, but to have something more. I mean, like Salvatore was saying, yeah, they are an organization. Maybe we can think about that to create or have an organization like CERN, something like that. And with this support, with the support that the CERN already have for us, like they say, and from I think the Fermilab as well, maybe Marcela can talk about that. We can go with their support and go to every ministry and have, look, we are organizing this organization or initiative, or I don't know, how do you call that? And with their support, let's try to say, okay, we're trying to organize a big community with all these scientific things that we are doing here in Latin America, okay, and try to get their support in order to get the funds. I mean, with an organization in our back will be much easier for everybody.
So let me just remind you all that when we were able to get into the different ministerial meetings, we went with the backing of CERN, of Fermilab, of particular funding agencies as well. We did that work at that time and that was something that helped us quite a lot when we were pushing to get onto that agenda for the ministerial meeting. So it's something that we know that we have to do. I'm pretty sure that we can reach out again and try to get backing again. I mean, it's a lot of work, and we are happy to do it. ICTP, of course, Fernando, I'm not forgetting ICTP, was also an important backer. But yes, I mean, it's an important point. And there are many dimensions that need to be looked at and worked on. And the point of this, again, is that we are all stronger working together towards this common effort as a community. Ivan.
Yes, perhaps I'm going again over the same subject, but to address the comment that Guillermo made and the comment of Fernando, yes, observatory like LAGO can be funded locally, but this is very trouble from some sides. So we have encountered our partners in Chile, in Guatemala, and other places that have a very hard time to get funding for locally. So that's why I'm asking in think about some global funding for the within LA, the LA community. And that's also in connection with something that Jorge said earlier this morning about and Xavier also posted something in Slack about the South Atlantic anomaly. That's like a problem that we want to study. So it's like quotation mark our problem in the sense that we have it here and we are interested in study this, and we have to understand this what of we are interested not only as looking outside, but look it inside and try to take these kind of things as science drivers. Nothing more.
Yes, I think that's a very important point. I think it's well taken. I think it's something that we are going to continue to reiterate when we try to focus on what is relevant in the region and what is, also relevant of the participation of the region in the more global scale. But both of those aspects are important, and I think that we've heard it, several times now throughout this week, and I think it's important. Hopefully the different conveners for the different subtopics that have identified specific projects around that will highlight that as well. I don't want to. Yes, Rogerio.
Sorry, it's quick. So it's a comment about what Jorge Molina said about having something in Latin America, some association or something. And some time ago when we started this, and I went around asking people to help, to contribute, because we're doing this strategy planning. The question I got many times is, who are you to do this? And then I told them, look, we are, it's a grassroots movement. It comes from SILA 5, blah, 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 blah. But then I was asked many times that I didn't have, the authority to do this. You know what I'm talking about. So I'm just saying that I was very impressed by the organization of the nuclear physics community in Latin America. They do have an association of Latin American nuclear physicists, which is recognized by UPAP. Okay. So, and I think this is a way, I think we should think seriously about starting something similar to have an association, a more, let's say, recognizable institution to lead this process. It's just a thought.
Yeah, I think, yeah. So I wanted to give Xavier Bertu the chance to tell us about the initiative. Let's say we close the discussion session for now. We have the final closing, and Xavier.
Okay, so let's hope that I don't disconnect in the middle. So we were discussing about the creation of a diversity and inclusion commission within the Latin American Strategic Forum. So I've had some private discussion with a few people who raised this issue, and so our plan would be to make this commission within a week or so. So by the end of next week, to define a group of, I don't know, maybe 5 or 6 people to discuss on that topic, to make a survey. There are very little surveys for the region. Some countries do have surveys, but for the region, there are very little surveys, especially in our area, which is what we want to do in high energy physics, and consider all the aspects of diversity. So we have some specific things in Latin America due to the idiosyncrasy the continent. Also, at the level of countries, I mean, we are talking about Latin America, but there are very few Central America countries represented. They are very small, and actually, when you discuss with them, the level of issues they have compared to us, the other countries, is very different. So that's something that we believe that a first review of the situation would be very nice, and then maybe within this committee try to make some recommendations for the community to be forwarded to the community through the Latin American Strategic Forum. So if you are interested in contributing, then please send me a mail, and within the next week we would like to finish that. So don't wait a week thinking about it. I mean, if you want to contribute to that, I'm sure you know that you want to do that. So just send me a mail right now, and we are going to organize that. I'm not sure I will be part of the committee at the end. We'll see. I mean, it's so just send me a mail so that we can organize a group, and then we'll see how we go on. The last point, please fill the request we sent, the form we sent. We already have 57 answers, so that's quite nice. So if you've not done it yet, please answer the form so we can start with something. Thank you.
Thanks. Okay, so we're really almost up. One thing that you might want to keep in mind, I hope Carla Bonifaci doesn't mind that I highlight that she's participating in the Equity, Diversity, and Inclusion group committee that's part of one of the subcommittees of the community engagement of Snowmass. So she may be able to also give some interesting pointers there. Rogerio, the floor is yours to close. And thank you so much to everyone from ICTP-SAIFR that has given us the support. But I especially want to thank Rogerio. Without being able to work with Rogerio on this, we would not have been able to have this symposium. So I really would encourage everybody to clap for Rogerio.
No. So thanks. But what I really want to say is that first of all, I heard many people when giving talks, they start the talk saying, I like to thank the organizing committee. I think it's the other way around. I think we want to thank you for submitting these white papers, to engage this effort that is grassroots, and really to participate in all of this. This is fantastic. So we really want to thank all the community that participated, that engaged. Not all the community was engaged. I have to say I was frustrated sometimes, but I think we did a good job. I think I'm happy in the end, and I think this is moving forward, and people will see that we're serious about what we're doing. That's really important. And so I want to thank especially the people from ICTP-SAIFR in São Paulo that are helping with this, especially Tiago Coutinhoto, who will probably send your files to him. He did an amazing job. He put everything in the page. He collated the files. He is filming this, so it's going to be public sometime, maybe not. And all the files are there, and yeah, so he did an amazing job. So thank you, Tiago. He's here, and yeah, so you keep going, and right, Marta. So. Yeah, so you have to start planning next steps, and so you keep in touch. You don't worry, you'll hear from us. You'll not escape. So so thank you very much again for this week. I think it was a very productive week. I think I learned a lot about all the efforts in the region, so it was amazing. And yeah, so see you some other time, hopefully in better times and in person. So I'd like to ask the organizing committee also to say some things. Oh, I already said, right? But
I would just be very brief and said two things. First, that I think that in the briefing book, we should at least put some paragraph, half a page or so about the COVID situation. I think that's important. And I think for that respect, I think would be very useful. I remember reading something that, for example, Balseiro Institute people were doing towards COVID. So if we can have a list of some examples that our community is doing, for all of you who are there, please send it to us, to Marta, Rogerio, myself, Xavier, and Fernando. just a link of something, correct? A link, because I remember this when I read it in Facebook, I think, but that would be very useful, because we would like to write a paragraph and then put the links of things that have been done by the scientists in the region helping for COVID. So I think that's good. And then other than that, I also learn a lot. Maybe I'm a bit farther away sometimes from each group, but it was a pleasure. It was a real pleasure to listen to all the science. And yes, we have not been able to attract everybody, but by showing that we are strong and we are going ahead, I'm sure that many others that were lukewarm at some point will want to jump into the train and join us. So thank you everybody. It was a pleasure to be part of this effort, and it's only starting. So.
Well, I will say something, let Marta to finish. And so yes, I want to thank everybody. I have been checking the number of participants. It has been almost stable for 60, and this is very impressive. And on top of that, the number of proposals and so on. So this is very exciting. I think the time is ripe for Latin America to get together. Unfortunately, as good that Tere reminded us also, is that the issue about COVID is going to definitely delay these things, but we should not give up. As I think Luciano was giving us some examples during the war and something. It's good that we show that there is this light still open, that we still keep caring about science and the development, and hopefully we'll be successful. We are patient and working hard together. I think we can achieve a lot. Finally, I would like to emphasize the point that Xavier mentioned, and is that there are many countries involved into these proposals, but there are a lot of countries which are not involved. And I feel that personally, because my region is not involved, Central America, and I will try to make an effort with my colleagues in Central America to try to contact some of you to see if they can get enrolled into some of the initiatives. I think there are people who are very capable, and they have been involved in LAGO or they're doing research in some other collaborations that I'm sure they can join. But it would be nice to be as inclusive as possible. And well, again, thank you very much, everybody. And it's a great thing to see the whole community together, and hope this will be successful in the future. Bye.
Okay. Well, thank you all. Bye.
Thank you.
Bye-bye.
Okay, bye. So, if Marta and Fernando, can you stay a little longer?
Thank you. Bye-bye. Thank you.
Bye. Thank you.
Like 15
Bye.
minutes.
Thanks.
Bye. Thank you.
Thank you all. Great conference. Bye-bye.
Bye.